Hi, my name is Bob Grinja and I'm a volunteer with the Martin Fleischmann Memorial Project. So thank you for joining me this late August evening for those of you in Europe and those of you stateside. It's a pleasure to have your attention, and this is going to be a mess, but I hope you're happy with some of the learning that we'll get out of it. I'm quite excited, let's put it like that. It's been a long journey. So what's actually going to happen is I have got agreement to give a presentation at the annual CMNS conference in Italy. I didn't make it to ICCF 24 because of my immunity not being sufficient for the American authorities, and that on Wednesday was confirmed will be still the case going forward. So I think this is the best opportunity. I'm going to make a call for support for that. It's going to cost about €1,000, but I think I need to go anyway. I will give them my the cash for the conference fee tomorrow. But I think this needs to be out there because it is, in my view, what's going on in all LENR processes that I have investigated alongside the wonderful team at the MFMP and all of the volunteers and donors that have made all of this possible. Now, I don't know how much I'm going to get through tonight. I'm probably going to ignore a lot of background material, and I'm sorry for those that might be seeing this video out of context or without prior learning. That's, I'm afraid, just the way it is. How do you condense 10 years, particularly the last 6 years into one presentation? Well, the answer is you can't, especially when you haven't got all the slides prepared, and I've hardly got any of the slides prepared. So what we're going to do here is introduce something that for me explains the initial concept I had for what was going on in the Lion and the Hutchison effect samples, and how these things are effectively therefore possible. And I believe that over the coming days, when you look at the references that I will add into the blog and consider them in their fullest, and maybe research through to the linked references in those papers, you will know, I believe, with certainty that this is a real thing. It is what is going on, and it's mind-boggling, the implications. It just really is. And I know I've said that before, but with every iteration in clarity, it dawns on me the significance of what we're actually discussing here. And I think probably this is what was agreed in the 1970s should not be researched between the two superpowers at the time, and I believe it has been researched. No one stopped, at least at certain levels. And it is inevitable that if you actually pay attention to what's going on in LENR experiments, this will be observed. And the title slide I have today, here, Ode, at the tip of the pyramid. What you are seeing here is something that I saw in my live recording when I was with Henk Uren. And I must thank Henk and his family for hosting me and for putting up with me and the way I do things, and Henk's patience and his determination in adversity to run these Vega experiments and to continually look to seek new learning and inspiration in a virtuous feedback loop. It's been a real pleasure working with him over the last couple of years. And so back to this particular slide here. When I was recording this video and he was describing what he had done, which was essentially, look, it looks like the Vega Valley has happened in a crack. Can we see what sort of crack it's in? He had this brass plate on top of a thick, soft iron plate. That's a magnetic plate. And he was very excited to show me this. And this is the top side. And he pointed out this hole. But as he was pointing out this hole, I said, I wonder if he's going to talk about the other bit. And he didn't. Because what I was more interested in was not the hole. Everyone's seen a hole. I was more interested in this lump. This hexagonal shaped lump. Anyway, we'll come on to that. So, this is O'Day at the tip of the pyramid, and I have this introductory text here, which I will read. And it is from a recent paper, Consa O. I think it's a Spanish guy, and we will look at that paper. And the paper will be linked into the blog at Remote View on my Substack, remoteview.icu. And it says here, in 1957, Zel'dovich discussed the parity violation of elementary particles and postulated that spin-half Dirac particles must have an anapole. In the late 1960s and early 1970s, Dubovik connected the quantum description of the anapole to classical electrodynamics by introducing the polar toroidal multipole moments. The term toroidal derives from current distributions in the shape of a circular coil that were first shown to have a toroidal moment. Toroidal moments were not acknowledged outside the Soviet Union as being an important part of the multipole expansion until the 1990s. Toroidal moments became known in Western countries in the late 1990s. What you are going to realize, if not during the course of this presentation, which is really just a read through of a bunch of slides and some reference to some samples that I acquired or got videos of when I was with Henk, is that this is the thing that Ken Shoulders was referring to. It is what was being referred to as the failed electrodynamics of the West that Tom Bearden spoke about at great length. And he referred to the fact that the Soviet Union had really grasped a much fuller picture of electrodynamics. And this really is a key component to that, to explain how matter exists. Hopefully, if I remember, you will also understand why we saw certain things in Lion and other samples. Particularly things like it misbehaving with electron beams and providing odd spectra in the form of a pentagonal or a sort of swastika or other structures coming back in the light. I think that this will explain that. I think it will explain the storage of magnetic energy. It will explain possibly what is on this page on 91. I've actually finally got a copy of Steps to the Discovery of Electronuclear Collapse here. And I think we'll be able to describe what is going on with this here. And this point of electronuclear collapse on page 91 of Matsumoto's book. And so much more. So really, for me, this is just a talk with you through some of my thinking over the last couple of weeks, how it relates to things that I've observed over the last several years, and the implications to a degree. So we'll see these diagrams a bit later, but you can see there's two toroids with toroidal movement on there, current, and you'll see here this says figure 4, geometric illustration of a longitudinal, there we go, and transverse toroidal oscillations. So these transverse toroidal oscillations. And this is in Dubovik VM and Tugashev VV 1989 at the Joint Institute for Nuclear Research, Dubna, USSR. Now, I've spoken about this area of nuclear research many times because this is where Shishkin et al. Works, and you will start to understand, I believe, how Alexander Shishkin is so certain of his magnetotoro electrical radiation, and you will see the commonalities between this and why he thinks the birdies are created with that. So, without further ado, I will talk about the things that led me to along my journey. So, this one here is the lion track, and if you recall, this image here was taken on 18th of September 2017, and we actually took images a little bit before this, and I sent it off to Alan, and he saw this structure very much smaller and asked me to say, have you seen that? What's that? That's Alan Goldwater, my esteemed colleague in California. And I thought, oh no, but I knew exactly how it would be mounted in the SEM. And I was able to go back to the SEM and find this structure again and take a closer image of it. And it's actually the logo for my blog, remoteview.icu. And in my view, this is what led me to have my initial, along with things that I saw on Hutchison samples, to have my initial concept of what was going on. So we have this kind of winged structure and this tail, and this, I believe, is very key. It's like a torsional moment going on here. One side is clearly bigger than the other, and there seems to be this void in the center. Now, if I play this, you'll see Shishkin's birdie here on an X-ray, and this is on a Hutchison sample, and it's got the same wings with the sphere in the center, and I've overlaid the collection there. Okay. Now, when I was looking at this sample here, that's the one that I picked out down here, this one here, and the two different ways of looking at it. But it was this one here that really, initially I couldn't explain. I think we've got a good explanation for that. I think you'll agree with me by the end of this that is the case. And it was this one here, and it seems like there's a rotational moment because it looks like something from here has been torn out and thrown over there. But this has like an empty cone. And over the years, I've thought that this was the Sothic triangle. In that it's a cone shape with a little cone inside, which is actually a void. And I think we'll probably find that that is the case. So, as I've said before, that this overall structure is effectively, in my view, the lower part of the Ankh, or the key to all hidden knowledge, and that is always associated with the Sothic triangle, which is a cone with a piece of cone taken out of it, if you know what I mean, or not removed, as it were. So that's how I interpreted this, and this bending off is very similar to what you see on the Shishkin birdies. I also talked about these, where this is kind of like side-on impact, and I viewed this as a sort of flat-on impact. And of course, at the time that I was looking at these materials, I wasn't really understanding the importance of the, how should we put this, the electrical state of the material. Was it a conductor? Was it a dielectric and stuff? But I think, was it antiferromagnetic? Was it magnetic? Was it diamagnetic? Was it paramagnetic? Obviously, I talked about those things later. But what I have done is I've highlighted on this, and you'll see that these are all sort of, how should we put this, north poles, in my view, because they are not damaging the center part. you've got an interference here, and these are south poles because they're ramming material into the center. This might be two south poles joined together here, actually. We've got a point in the center there, point in the center there. So, and I've just discussed these many times. So this is from the top view. This is actually looking at the inside of a piece of quartz. So in this case, I have one of these EVOs actually on the outside of the quartz. But the ones you're seeing in this image were actually scored on a different Lion reactor on the inside. So that is all on the inside of the fused quartz. Now, there was this one, which was what I called the cannon, and it appears to have something on this side and something on this side, and there are a number of flux loops. So we have a north over here, and a south, and a little one over here, north and a south, and you can see that the norths have a hole, and the souths have a splat. And so that is the north and south. Now, I struggled with this for a long time, thinking, is this going through the material and round and back? But I don't think it is, and I think you'll agree with me by the end of this presentation that that isn't what's going on. But this was one of the things that showed that this was able to manipulate matter. So this is manipulating matter. It's maybe not melting it, but it's damaging the crystal bonds between the silicon and oxygen in the quartz. This is, it would appear, shifting material. And one is an outie and one is an innie. Now, this was very curious. This was in one of the diapad nickel abrasive pads from 3M, and this is one of these little several millimeter discs, and this is where the synthetic diamond would sit. And actually the diamond is gone, and what we have is a round carbon tube. I don't know whether it's a tube. I think it's actually a rod. It's like completely like a rod, but it seems to be largely equidistant from the boundary of the nickel hole cavity in which the diamond was. And so I imagine that something like one of these was in there, a north pole, and it's stuck down in the bottom of here, and it's throwing the material out. And for some reason, it is able to make the carbon into kind of like a non-crystal state. So there's changes to the crystal structure in this one without it going over its melting temperature. The reactor supposedly never went above 1050 degrees C. And in obviously the cuprous and cupric oxide in, where is it? Here is being shifted around, things being done to it. And in here, the diamond is maybe becoming some sort of amorphous thing, and it's being shifted. And is this actually a flux loop? I mean, it is definitely bending. So was this bending over and effectively joining another one over here? But you know, where the central part, the coronal rain area of the flux loop met something else was going on. I don't know. And then I saw these two spots on X-rays. I'm sorry, I'm not going to go into that at this point in the presentation for those that haven't seen it in the past. But there were these mirrored structures that didn't seem to particularly care about each other. They weren't affected by each other. But I asked at the time, what are these kind of pointing at? Well, I think most recently on the 2nd of, I think it was June this year, I took this image, and this is one of the outside parts of the cupric and cuprous oxide that was contacting the inside of the quartz. And I say this is Eye of Ra and Eye of Horus. But actually, these are equivalent, in my view, to some of these, just not so close together. So these are the mirrored ones here, and this is a mirrored one. But they are actually this kind of loop. But I believe, actually, the triangle is actually where you have a flux loop of one chirality on one side and a flux loop of the other chirality, and it's something that's joining the two together. And so there's something that comes from here and here. And this exact structure was found also in Solin's work. And I think actually I'm going to go to that. So I'm going to go to my slide. I think it was from... Let me see. I think it was from Coherent Matter Waves Part 1, not 2, 1. So let me see if I can find that. And that will be on here. What am I looking for? There we go. No. Just give me a few seconds here. I'll have a look at your... Oh, congratulations, David. We've got some good news, have we? Oh my God. Hold on. Sorry. Breaking news. For those that can't see the chat, I think David... I want to thank right now David for all he has done. Obviously, the Coherent Matter Waves Part 2 that I'm just looking at here is... So, David, what am I missing? Have you had a... All right, I don't know. Okay, I'll wait until he says again. I can't go through there. Okay, all right. Let me find this. Okay. Give me a second. What am I looking for? Okay, so it is in Coherent Matter Waves 1. In fact, there's a lot of good stuff in here. Yeah, so what I was referring to is this. And this is again on the quartz liner, and two different types of poles on there on the quartz liner. But this is also in Solin's. Okay, so this is the triangle, and I kind of believe that this is either a cluster or one loop of the structures, and this one's at an angle. So those are the available options, and I said it was essentially this. Okay. Okay. So like I say, this is going to be a little bit scrappy to begin with. So, what you are looking at here in all of these things that the Lion track is on is cupric or cuprous oxide. But definitely there's a whole lot of cupric oxide there. So that is CuO, cupric oxide. And it formed this super glassy state. There's no crystal structure here. And if you recall that this was part of the Lion 1 reactor, that when it was turned off, it was attached to a light bulb, and halogen light bulb with a drain, and it lit the 20-watt light bulb for about half an hour, according to the Lion claimant. And there was a sucking sound, and I predicted that when I looked at this, it would be because there was a drop in temperature. In fact, to create this kind of glassy material, I believed from what I'd learned at Francesco Piantelli that it needed to be 1,000 degrees per second, and he said it was about 2 seconds. And given the fact that he heard this sucking, crackling sound, and so given the fact that at the time I thought it was over 850 degrees, I expected this to reach extremely low temperatures. And then someone who had access to the SD card, who had not told the Lion author that they had found a data anomaly, found that in this data the temperature had gone from the observed temperature, which was parallax offset at about 800 and something degrees, down to minus 273 degrees centigrade or thereabouts, given some inaccuracies in the coefficients applied to the thermocouple. And so that was fascinating, because this lined up with my understanding about cold electricity. When these structures break up, the electrons need to regain their thermal energy. And so they are real electrons, they are released, but they have low temperature, so they have to absorb all the thermal energy from their environment. So it cools down, but real electrons are released. So the two things allow for the observed phenomena. Okay, so is there any evidence or in the literature that cupric oxide could lead to what I believed it was leading to? And what was I saying it was leading to? Well, I need to go to a different presentation for that, so give me a second. Like I said, it's going to be a bit disjointed, sorry, so you can talk amongst yourselves. Oh, I'll get it from my blog. Okay, so it was this image which I drew having had a sleepless night that came to my mind, and this was the magnetic core, and this was the cone coming out, and this is a split toroid, and these were the wings. And so that was drawn in January 2018, and I shared it first in Sochi on 4th of October 2018, just under 4 years ago. Okay, so that was the structure, and what significance does this have? So I'm saying that this here, this structure, is what caused the birdies in the lion, and also in the Hutchison samples that I was looking at. And so I went from September 2017 to early 2018 and came to the conclusion that this is the structure that probably is doing Lena. I don't actually know what it is, but this is the thing that I could use to explain from the physical evidence, you know, how that physical evidence was created. So we have some sort of torsion going on, something is coming in here, and there was another one where it's coming out, and so you would have the opposite of it, and you would have this kind of structure going around there. So, okay. Well, it just turns out that, like I say, the anapole was not taken seriously by the West until the late 1990s. Of course, Ken Shoulders had a different view of what we are talking about here, but if we go back to here, there is a paper, believe it or not, where it says observation of orbital currents in CuO. Observation of orbital currents in CuO. And so what you actually have here is a copper atom, and oxygen, and oxygen, and oxygen, and oxygen. So we saw our pore tracks, our line track in CuO. And this creates an orbital current going around that like this, which is essentially exactly what I drew in January 2018. And this creates a up vector and then a down vector. And this is the current loop, so that's a magnetic flux ring around there, and this is what it looks like. And this here is your toroidal moment. Okay, so I've referred to this before. I did not and have not read Ken Shoulders' EV: A Tale of Discovery, despite the fact that I had a hand in releasing the PDF which had searchable word terms in it. I did that because I wanted to clean room it. I wanted to be able to see things first and try and physically work out what they meant in my head before someone told me what they were. So literally I only found what I'm showing you here in the last 2 days. Okay, but what I did state actually in last year in Azizi was this, which I've copied more directly. I saw it on Rex Research about EVs, and apparently it's from the back end of EV: A Tale of Discovery, and in fact I can show you that it is. So if we go here, we go to where is it? I can do that. I can go here. This is EV: A Tale of Discovery, and this is basically the last page in EV: A Tale of Discovery, and it's here, and I've just copied it here on the slide. And it says, by some irony of fate, we may have folded back upon ourselves, and now we have accidentally discovered that the EV as an ideal monopole oscillator. This oscillator is the perfect generator for vector and scalar potential waves without contamination from either E or electrical or magnetic fields. These waves can be thought of as longitudinal waves in the vacuum. They are largely undetectable by standard electrical and magnetic detecting means, but are readily accessible to the monopole world. There appears to be an incredibly large number of useful phenomena yet to arise from using potential effects that are not immediately accessible to the force of electrical and magnetic fields. This phase-determined, force-free world will certainly be another chapter somewhere in the future. Okay. So that is that. Okay. So I'm going to start running through some of these papers. Like I say, I'm not going to go over all the material. For me, this is kind of a talk-through exercise with you guys to start thinking about what I want to present in Azizi in around about 4 weeks' time. So before we go there, I have this slide here again from the monopole clutch video, and it's by John G. Kramer in 1983, so take that on board when that occurs. And it's when a proton meets a monopole. Okay. Consider then what will happen if a massive monopole comes very close to a proton, attracted perhaps by the small magnetic dipole field which every proton has. The quarks within the proton would have a reasonable probability of encountering the core region of the monopole, and when this happens, the quarks are very likely to forget their identity and be changed to some other flavor of quark or lepton. If this happens, proton decay becomes a near certainty, but the monopole, the cause of it all, is unaffected. It is still stuck with its surplus of magnetic flux, so it cannot participate in the decay process. Thus, the monopole is the analogue of a chemical catalyst. It is an agent provocateur. It wanders through matter, stimulating proton decay and nuclear breakup without being changed itself. A single monopole can do this over and over again as rapidly as it can find its way into successive protons or nuclei. And with each such event, a quantity of energy is liberated, which is far greater than that released in uranium fission. Okay, how much greater? Well, uranium fission, uranium has, say, 235 nucleons. When you fission uranium, you get an average of about 200 million electron volts, 200 MeV. And if you divide that by 235, you have much less than, I think, 0.9, or certainly much less than 1 MeV per nucleon. Actually, DD fusion is more than that. It's 25 or whatever it is, MeV, let's say, ballpark. And you've got 6. 6 into that is, well, it's not a lot, is it? So 6 into 24 is whatever. It's 25. It's not like more than about 6 or something. Round there. If we look at the David Freiberger paper, which is another one that says the diality angle of the torus, like Tor structure, if it exceeds a certain threshold, that will cause the decay of a baryon, let's say the proton in this case, and that will release around about 1 gigaelectron volts. And in the case of ball lightning, which he is doing a model for, the coherent matter will effectively downsample the emitted parts of the nucleon, and most of the energy is realized into about 90%, and some of it's lost as neutrinos. So if we take 90% of 1 gigaelectron volts and we divide that, we are getting something like 166 times more energy than fusion, which is the most energy we know about. And I believe that this was the technology that Boyd Bushman was referring to in his video when he was referring to John Hutchison and Lockheed Martin looking at technologies that are way beyond fusion energy. I believe this is it, and I believe this is the end of the road. And if you consider even if it's just like 150 times more energy, that you yield out than fusion. If you take carbon and oxygen and you oxidize the carbon, doing basically the carbon economy, that gives you around about 5 electron volts. If you're getting, let's say, per nucleon 5 million electron volts, well, actually, you've got a lot of nucleons in carbon and oxygen, so per nucleon it's a little bit unfair, but just say per chemical reaction, and then the nuclear reaction per nucleon, you're getting sort of an order of like 1 million times more energy. If this is 150 times that, but you're not getting a pathetic yield, you're getting a very high yield because you're directly converting to light and electrons. We're talking about 150 million times more energy than the power that drives the current world economy. 150 million, which means that this planet could comfortably support, in energy terms, trillions and trillions of people, in my view. So, and unless we allow people to claim an era of scarcity, we have at our fingertips the ability to have unimaginable abundance. And I think people would, really appreciate that message right now. The level of which this is so much further than even the discovery of nuclear energy. It's way, way more than the discovery of coal and oil and gas. But way, way, way more than fusion, which they're all trying to achieve. This is way, way, way beyond that. There's no need to be shutting down the Haber process because no one can afford oil and gas. You may be able to make all the synthetic oil and gas you need from just the conversion of the energy, but you'd be able to find a good process to create ammonium nitrates and so forth, and run everything with hydroponics from desalinated water, whatever you needed to do. When you have that level of cheap energy, the sky's the limit with what humanity can do and be. So we are at this point fork in the road, as it were. Do we accept that this technology does exist and that we're not allowed to have it? It's only going to be used for weapons and keeping us under control, or do we accept that, or do we take the view that we want to make this happen for the future of the planet and future of humanity and our ability to go forth and multiply in the rest of the universe? I would say that would be the case. Okay, so was there any other slides that I wanted from this particular presentation? Okay. So this is the paper that refers to that cupric oxide thing, and this is observation of orbital currents in CuO. Orbital currents are proposed to be the order parameter of pseudo-gap phase of cupric high temperature superconductors, blah, blah, blah. Anyway, I think the only thing you need to take away is that this is a top-down view, that you have your copper atom and then your oxygen atoms, and so you can create these orbital currents, and this is effectively creating your toroidal and your toroidal motion. And if you go down here, a toroidal moment, that is this, is associated with the orbital moment L or spin S, and is proportional to R times L or R times S, respectively. This will make sense when you read some of the other papers. Okay. So, the next thing I'm going to show you is a little bit of a diversion, but it is to do with, I believe, how all linear is working. And so what we're saying is we need to create these toroidal structures. You'll understand why we're getting these triangles that I've spoken about so much in the past. But how do we get those? Well, we know that if you have turbulence, dichotron instabilities, in fact, any kind of instability, you'll get vortices forming. And the classic one is if you've got to push forward like a plate in a swimming pool, you get the phallico-soliton in the swimming pool forming. But also, if you have electrons being emitted from a tip, as Ken Shoulders did, you will get a smoke ring type electrical vortex. Now, there's one that I hadn't considered before, and it's in this paper here, and I think it's incredibly interesting. I think people should read this paper and spend some time with it. But it is in 2017. It's the dynamics of vortex-antivortex pairs, and this one, rare refraction pulses in liquid light. Okay, forget about the liquid light. It's just a fluid medium. Okay, and the one that I am interested in here is this one here. These are traveling waves, solitons, and the one that I think, the two that I think are most important here are this one, which is a section through a vortex-antivortex pair. Okay, so this is, you can imagine a whole ring vortex soliton, and so you can see the flow going around. So this is similar to my proposed model that came to me in my sleep. This actually here is what's called a rare refraction pulse. What's that? Well, a rare refraction pulse is when you have a medium and you push it and pull it, and there's a slight change in density in that area where you've pushed and pulled it. So, but of course, if it isn't the same over all of the areas, so like some areas pushed more than others, then you will end up with a rare refraction pulse. Okay, so I don't know if that made sense to you, but basically, effectively, you've got a faster moving bit in the middle, and so it kind of pulls bits into the center as it's kind of moving forward. So it's some way between a ring vortex soliton and another. Well, it is a soliton itself. It's a traveling wave, but it is actually a vortex. Now, the interesting thing is that when these collide, they can actually produce solitons. And so what this means is that if you have pressure waves traveling through a medium, whether that be an ion acoustic wave in a Vega experiment or a dusty plasma experiment, so like the nova or supernova reactors, or if you have sound traveling through liquid mercury in the Cardone et al. Experiments, or if you have sound waves, pressure waves traveling through a metal medium, then all of these things are effectively these solitons. And see how this plays out. There's a video that's associated with this, which is on YouTube. And again, I will provide links to these. And here it is. So you've got two solitons coming in here. Now, I don't think the description is quite accurate compared to the paper. It says here, collision of two bright solitons. This is in liquid light. With a bigger one is described by the cubic quintic nonlinear Schrödinger equation. Two vortex-antivortex pairs are generated in the process. The head-on encounter in which the vortices of each pair meet each other drives the two separate dark pulses, which comes out at different angles from the incoming one. So just watch this. Right, do you see? We've got a vortex and two vortex-antivortex pairs. Okay? Coming together. There's a bit of merging going on in the center there. And they come out, blah, 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 blah. Again. Okay. So, I guess one part of my realization was that we know that, for instance, in Henck's Vega experiment, there are sound waves. We know there are electrons and there are protons in there, especially when we put hydrogen gas in there. And even when there's just water in there, there will be ions moving around. And you get these ion acoustic waves, which can be pressure waves, and they could manifest themselves as full vortex solitons, but they could also manifest themselves as these rarefaction pulses. And when you get these rarefaction pulses colliding with each other, you can imagine that that would lead, as you saw in this simulation, to vortexes being formed, vortex-anti-vortex pairs. And when those start forming, you can then have effectively what you see in the swimming pool, which is a phallico-soliton joining up. And we know if you get a phallico-soliton working sufficiently that it comes up, you can then have, as they did in the pulses from Bostic in the 1948 onwards research attempting fusion, you can have the current loop joining back together and forming a soliton at 90 degrees to the emission pulse, if you know what I mean. So I believe that this kind of thing can be occurring in fluids, in metal fluids, in ion acoustic waves, and so forth, leading to the production of solitons in situ, and particularly in the case of standing waves, where the resonance of whatever cavity it is leads to a cymatic pattern in a 3D volume, where you've got resonance modes in that area. And this speaks to what Solin was talking about. He was firing a free electron beam into his low vapor pressure metal, and this would lead to a melt zone, which would have a phase transition, a hard phase transition. So if he was using zirconium, for instance, it would, the electron beam coming in would melt a zone out of that solid piece of zirconium, and you would then have a hard chamber of zirconium with liquid metal in between, and this would form resonance. And in fact, it describes in his patent very specifically that it finds its own resonance. It's a self organizing system where it creates an environment where it leads to the standing waves, and the standing waves are effectively going to lead to intense areas of pressure and so on. And so I believe that is what would lead to a ripe environment for production of vortex anti-vortex pairs, which I think can link together and therefore form solitons. These things can have flux energy encapsulated in them, and then they can then join together as we've described in other presentations. Okay. So, yes, and Corky's saying, yeah, cracks of Matsumoto. Okay, so I don't know whether there's much more I want to say in this. Coherent generation of vortex-anti-vortex pairs, so it's showing you here how this is forming, and we've all known this. And this is a lot of modeling going on, but we've seen these things in the flesh. So I encourage people to look through this paper, Collision of a Rarefaction Pulse with a Vortex-Anti-Vortex Pair. So they're modeling. And it's interesting because I'm going to show you something later, hopefully, maybe, if I've got it. This T structure here. Just hold this T structure in mind. And this is a collision of a rarefaction pulse with a vortex-anti-vortex pair. I believe that we have seen this in a recent sample from Henck urine. And we've seen lots of these vortex-anti-vortex pairs and so forth. So, yeah. And this is head-on collisions of two rarefaction pulses. And I believe that we're seeing these kind of things going on when we look inside the plasma. And I have to say, thanks to Stephen and to Charles for enabling the purchase of the equipment that was able to allow us to look right into the plasma and to control all parameters from you know, 1/50th of a second all the way up, or even longer, all the way up to 1/32,000th of a second, and change the f-stop and so on. The information that we got out of that, even on just the first attempt, really is just, it really bodes well for the future. And I want to thank DK1205 or whatever his name is. It's just not an easy name, because he helped support that trip. So thank you to him also. If he's about, thank you. My hat's off to you. So really fantastic support that we got for that trip, and it really made a difference, actually. Okay, so now remember what I was saying at the beginning, that according to, and I'll come to the paper that cites this, but essentially what I was saying at the beginning was this: that in 1957, Zel'dovich discussed the parity violation, blah, blah, blah. Dubovik connected the quantum description of the anapole to classical electrodynamics in the 1960s and 1970s. Toroidal moments were not acknowledged outside the Soviet Union as being an important part of the multipole expansion until the 1990s. This is, I believe, as I said earlier, what was being referred to by Thomas Bearden as the Soviets being so far ahead of the West in terms of electrodynamics. Okay, so I have this paper here now, which is Electrodynamic Toroidal Excitations in Matter and Free Space. And this is Progress article. And this was published 24th of February 2016. The toroidal dipole is localized electromagnetic excitation, distinct from the magnetic and electric dipole. So this is almost sounding immediately like what Ken Shoulders was writing in 1987. As a current loop, the toroidal dipole corresponds to currents flowing on the surface of a torus. Now, in all of these instances, they are only talking about the single tor. They're not talking about tor of tor of tor, or a tor of a tor of a tor of tor. But anyway, there's plenty to go on here. Just looking at this, they're talking about how there's a nuclear toroidal moment at 5 femtometers. There's proteins, and I was interested to see this, where you have a torus and it's twisted, or rather, maybe it's rotating as it travels and it presents itself. But I think it is being twisted here, and this looks extremely like both some of the coherent matter traveling waves we've observed, but it also looks like the interaction with the aluminium foil that I recorded earlier this year in a ultra experiment, where you had this essentially event horizon where I believe the coherent matter is moving through the aluminium foil and leaving this 1 micron braided structure. And I think probably the 1 micron braided structure is to do with the subtor interactions with the surface. If you can imagine the fixed, non-rotating tor on the Hutchison fracture sample that left these different paw prints, these different footprints at different quantas, this would be a rotating one going through the surface. And anyway, it's got various different examples there. And I actually found this paper shortly after I was getting into this idea, and I kind of put it to bed. And I think Axel sent it to me more recently. And it has a model here where this is the electric multipoles, quadrupoles, octopoles, the magnetic multipoles, and these are the toroidal multipoles. And when they are looking at the toroidal multipoles, they are doing analogues of quadrupoles and octopoles. They are not doing the clusters that I am talking about. They are doing the analogues of the quadrupoles in the magnetic and electric multipoles. So it's not quite the same thing, but at least for the single dipole, where you have the toroidal moment here, which is not the same as the electric and the magnetic multipoles. You'll see in a second. So we'll skip all this. We're definitely not going to do any maths. I will note to you, it says Aharonov bomb type effects associated with non-radiating potentials are only possible in static situations, right? Okay, Aharonov bomb is key to the Lockheed Martin patent. and so on. So these are different patterns of metamaterials that are able to produce these toroidal moment structures, and you can investigate these in your own time. I think this is useful to the Vega experimenters. They might want to create, in fact, one of the other papers I will show you will show this in more detail, but effectively it's a load of figure of eights cut out of metal plates at a distance, and then they've got the incoming wave. So they might think about that. This you might have even seen on my Hacking the Neutrino Verse, something similar to this, where I held up two magnets to my CRT screen and produced this very exactly the same pattern actually as this. But also on the blog post that I published today, you'll see that the image for that blog post, not the one that I published, but I published the Y remote view.icu. You'll see that I had a magnetic paper map that essentially is this, but in that green look that you get. But this is what I want you to see. And bearing in mind this is from whenever it was, 2016. Okay. With appropriate phase difference. So, okay. Non-radiating configurations. Such configurations consist of a toroidal dipole. This is different from the electric and the magnetic dipole. You will understand this, I hope, by the end of what we're going to talk about tonight. Represented by a solenoid with an oscillating poloidal currents. And so oscillating poloidal currents. And an electric dipole here. Represented by a pair of opposite charges, oscillating on the same frequency as the currents. So the dipole is going up and down, and the poloidal current is going up and down. Okay. With appropriate phase difference and oscillation amplitudes, destructive interference takes place. The combined source does not radiate electromagnetic fields. However, the scalar and vector potentials associated with radiation of these dipoles do not cancel, but instead propagate to the far field. Hence, a non-radiating configuration acts as a source of electromagnetic potentials, but not electromagnetic fields. The physical significance and detectability of these potentials are not established and are being actively discussed in the literature. Right, okay. So we may be able to find two different ways that these can be detected. Why don't they want to tell you how you can detect these things? I can tell you why they don't want you to tell you how, why they don't want you to know how to detect these things, because that is the same way that you would energize these things. But I'm going to tell you probably how you energize these things. And guess what? It's what John Hutchison was doing. Right, so let's go back to EV, A Tale of Discovery. By some irony of fate, we may have folded back upon ourselves and now have accidentally discovered the EV as an ideal monopole oscillator. This oscillator is the perfect generator for vector and scalar potential waves without contamination from either electrical or magnetic fields. These waves can be thought of as longitudinal waves in the vacuum. They are largely undetectable by standard E and electrical and magnetic detecting means, but are readily accessible into the monopole world. There appears to be an incredibly large number of useful phenomena yet to arise from using potential effects that are not immediately accessible to the force of E and electrical and magnetic fields. This phase-determined, force-free world will certainly be another chapter somewhere in the future. Okay. So that there was in 1987. 1987. This is in 2016. 20 years later, roughly. 87, 97, 30 years later. Is that right? 87, 97, 30 years later. 30 years later. And they're still saying the same thing, right? Okay, to be fair, it took 10 years for the West to wake up to what the Russians were doing. But still, here, 20 years on from that, they're still saying the same thing, as is said by, without crediting him, Ken Shoulders in his book here. Okay. Anything else of use here? It has already been shown that they couple efficiently to toroidal antennas, which may be used for their detection. I can tell you, when I visited John Hutchison in his location, he has a lot of toroidal antennas. If you go and look at the Hutchison file. He has a double-ended, I think that's important, double-ended Tesla emitter, and then he has around it a toroidal coil. His ray gun has a lot of toroidal coils held between, and this is going to be important, static accumulators. Why is that important? That produces a static charge. That is a field across a toroidal emitter. And it's, when you understand, it's just so clear how the Hutchison effect was working. I think this will become clear to you, maybe during this presentation. Okay. Right. So what have we got next? These are in no particular order. So, again, all these papers will be shared. This is communication physics, and this is from... when is it from? Don't know. 2019. Okay? In nature.com. Okay? The anapole... I'm going to change my mouse over here. I'm going to kill this. I am going to kill this. My computer going to die on me. For some reason, some reason. Okay, all right, don't worry. The anapole, a non-radiating charge current configuration. The anapole, a non-radiating, that's a non-electromagnetic wave, electromagnetic radiating configuration, was recently observed in a variety of artificial materials and nanostructures. We provide a brief overview of this rapidly developing field and discuss implications for spectroscopy, energy materials, electromagnetics, as well as quantum and nonlinear optics. Okay. Static toroidal dipoles, also known as static anapoles, introduced by B. Zel'dovich, that's that guy again, in the context of parity violation in nuclear physics, so that was in 1957, have been observed in magnetism and could be the only allowed electromagnetic form factor for dark matter candidate particles, right? What am I talking about there? Magnetotoroelectrical radiation, or N radiation. Now, there's a debate between Alexander Parkhomov and Alexander Shishkin. And Alexander Shishkin is saying these magnetotoroelectrical radiation is a cluster of the things that Alexander is talking about, okay? They are basically the same thing, but they are effectively dark matter. They are energy encapsulated in, I don't know, is this the Black Evo? Is this the electromagnetic phantom? Are we actually bathed in these things when we go out? Oh, I think I need a glass of water. Right. So, here we go. The structure of a dynamic anapole. Anapole is a balanced superposition of electric and toroidal dipoles. Electric dipole corresponds to a pair of opposite charges. Toroidal dipole corresponds to a poloidal current on a torus. Anapole emerges when the fields radiated by the electric and toroidal dipoles cancel each other out. So, if there's no electric charge presented and no magnetic charge presented within a region, would this be able to walk through things? I don't know. Is that an exotic vacuum object? Of course, with these things, you get to see them. Electric P, magnetic M, and toroidal. Okay? But this is the anapole. Emits no radiation because they cancel each other out. Okay. So, detection of anapoles. Recent detection of anapole modes in a diverse range of structures is a significant achievement in the field of toroidal electrodynamics. that illustrates the independent physical nature of electrical and toroidal dipoles despite them having identical far-field radiation pattern. See recent discussion, blah, blah, blah. Indeed, although their far-field emission patterns are identical, the electrical and toroidal dipoles correspond to entirely different charge and current distributions. Furthermore, oscillating vector potential emitted by electric and toroidal dipoles differs in a way that is irremovable through gauge transforms. Anyway, so actually we've got a better image here of what I was showing on the previous one. But essentially, a lot of these structures are just dumbbells. Or, how should we put this? They are figures of 8. Oh dear. Oh, I love it. So yeah, figures of 8 along a line here. Figures of 8 in a metal plate. Figures of 8 bored through some material here. Figures of 8 in a loop with it's the same structure as this. This is one of the plates and this is a group of the plates. These are effectively creating figures of 8. What are we seeing everywhere? Is figures of 8. Okay. Oh dear. Right. So I'm just going to pick out a few things that I want to say here. So the dynamic anapole, a non-radiating energy reservoir. The dynamic anapole, a non-radiating energy reservoir. You can put energy into this, you can put energy into this, you can put energy into this, you can keep putting energy into it. It's crazy to think about what you can do with that. Okay, so I think that's all I want to say from that one. Right, so now we're going to go back in time. We're going to go way, 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 way back in time. And this is not so far back in time, but it is July 1989. And this is again is by V.M. Dubovik and V.V. Tugashev. Toroid moments in electrodynamics and solid-state physics. Received July 1989. Okay, and this is at the Joint Institute for Nuclear Research. This is the GINA at Dubna, USSR, the Soviet Union. And this is where Shishkin works today. And so you'll get an appreciation for how he really knew his business when he was talking about magnetotoroelectrical radiation and methods to shield thereof. Okay. And of course, 1989, you might remember that year. There was something that happened in March that was quite interesting. But given the fact that this guy was doing this works from the 1960s and 70s, this is some time on. And this paper goes into really some real extreme detail. So first off, I'm just going to say it. The measuring moment of toroid dipole via torque. Okay. So it follows from the expression of this section that the toroid dipole moment is the only characteristic having an interaction energy from which one can directly measure the displacement current. In practice, it could be measured on the basis of the torque of a small toroidal coil placed between the plates of a capacitor. We may also mention that this system is an electromagnetic motor of a third type. By the first two, we mean a magnetic dipole rotating in a magnetic field and an electric dipole rotating in an electric field. A fourth type of motor could be designed on the basis of the axial toroid moment. See section 6. Okay, the important bit here is that in practice it could be measured on the basis of the torque of a small toroidal coil placed between plates of capacitor. I don't know whether this is to do with the torque sensor for the strange radiation emissions that was done by Zatelepin and Baranov. I don't know, and it could be. But I would suggest that if you have a 500,000 volt Van de Graaff generator or Tesla coil, and that's producing an electric field, and then you have a whole bunch of toroidal, that is a toroid of a coil as an antenna, and you oscillate energy via that, potentially extremely high frequency energy derived from a Tesla coil, and a spark gap, for instance, you could get to a situation where if you were able to put these anapoles, these exotic vacuum objects, in their non-electromagnetic interacting fashion into a metal sample, for instance, you could then charge them and they would build their energy and get excited and do some things. And we'll talk a bit more about that later. So down here we've got Simultaneously long. Okay, so where are we? Since a dipole is a system of 2 charges, poles, a quadrupole is a system of 4, etc. However, there is no need to appeal to charges in constructing higher multipoles. When there are no charges, see the note in Appendix B, all higher moments can be generated by dipoles. We have recently shown in reference 7 that in correspondence with the duality, and I think this is diality, okay? He's using the word duality in 1989. I think Freiberger changes that to avoid confusion. To diality principle, configurations are allowed which model the polar vector and axial pseudo-vector toroid moments. Anyway, there's a lot to go into this, but I'm just going to skim this because otherwise we'll be literally here all night. Okay. Effect of toroid moments. Searches for the effects described by toroid moments are still becoming more popular in different fields of physics. Okay, this is in 1989, before the West woke up to this, despite the pleadings of one Thomas Bearden. However, these investigations are a sequel to the previous series of papers by one of the authors, and this is the lead author here, sorry, I forget his name, on introduction of relativistic form factors in the case of non-conservation space and or time symmetries and study of their experimental consequences. Specifically, in connection with the observation of CPT, non-conservation, we have estimated the toroid quadrupole moment in the deuteron T, and suggested T2 and suggested a scheme to measure it in elastic ED scattering. The experiment has been done at Stanford Linear Accelerator. Oh, that'd be where Freiberger works. But the desired precision has not yet been reached. In the field of atomic physics, it is pointed out that the inhomogeneous are non-. Okay. Zeeman. Okay. What am I saying? Wait, what's useful here? Okay. Okay, so there's this point here about internal conversion. Okay. Like I say, I'm going to do smaller presentations which will deal with each aspect, but essentially if we go and look at what internal conversion is here, let's go and look at internal conversion here, because this is relevant to tractor beam, which is a presentation I did when observing some unusual phenomena on the lion sample. Let me get that, actually. I think I've got it here. Okay. Okay. So, if you don't remember this, essentially we are looking at part of the lion core, and this is cupric oxide, which we just, the CuO, which we've just been talking about, and I found this 4-point structure, this swastika here, and this 5-point cluster here, and when we play this, it has this weird thing where there are these kind of yin-yang structures around the outside. And I imagine this to be a torus with tori around it. And so, that being the case, how can we have these things where what was happening was we weren't getting the frequency of light back from the sample that gave us the real elements that were in there. So if I go here, this says hafnium and ytterbium, and I don't believe there's any hafnium or ytterbium in there. It's just a misreading. And if you have internal conversion, basically what happens when you're using EDS, you're firing these high energy electrons into the material. It excites some of the electrons in there up to a higher orbital, and then they drop down and they release their characteristic X-rays. Now, with internal conversion, what happens is the photon is interacted with the electron, it knocks out an electron or whatever it is. Or so I think let's actually look what internal conversion is before I make a mistake here. Internal conversion is a non-radioactive decay process where an excited nucleus interacts electromagnetic with one of the orbital electrons of an atom. This causes the electron to be ejected from the atom. Thus, an internal conversion is a high energy electron is emitted from the radioactive atom, but not from the nucleus. For this reason, the high-speed electrons resulting from internal conversion are not called beta particles, since blah, blah, blah. Anyway, I think this may help to explain what's going on. Like, this is not a very well-formed thought, so I'll probably move on. So, where are we? We go back to the paper. Okay, so in reference 75 and 76, a remarkable fact is indicated with regard to that a massive Majorano neutrino possesses only two internal characteristics, spin and anapole. Actually, a toroid dipole, since in the context of the problem studied, the anapole is not physical quantity. Recently, proceeding directly from this, it has been proved that the electromagnetic properties of any majoron can be described by toroid moments only. So the significance of this, that might not mean much to either. Okay, so you might have seen this before. This is your force-free toroid. Okay, you might have seen this before. This is in a 1989 paper by V.M. Dubovik. The other papers that he references here is 1967 and 1970. So his dissertation was on this, right? This is his dissertation in 1967. And then he refers to a paper in 1970 and then one in 1974 and 1983. So they're all over this. And then the first reference that isn't one he's done is the Zel'dovich paper from 1958. Okay. All right. Now, okay, so here's the thing. Therefore, combined transferred toroid photon oscillations can be described in terms of polaritons. This will please Axel. With the dispersion law of that, they could be detected in experiments on Raman scattering in the infrared frequency range. Okay, so this is maybe one way of detecting it. This is how you work out the magnetic charge of these things. So I'm not going to go into the maths, but we're talking about magnetic charges. So here we have very clear understanding in the Soviet sphere that these things exist. They're knowing about these things because he works at Dubna in 1967. That is his dissertation in 1967. So from 1967 to the publication of Solin's patent in 1992, you've got a long period of time where in the Soviet sphere alone, they have a good understanding that this is possible. Okay, so here's the thing that I really want to pull out of this paper. It's the precession. One can visualize toroid oscillations considering an alternating current in a toroidal coil. The alternation of the current density gives rise to change of the coil's toroid moment, and besides the oscillations relative to a null position may be both transverse and longitudinal. Generally, both the value and the direction of the vector t change, the toroidal moment. For instance, varying this at the fixed position and size of the coil, we obtain longitudinal oscillations. One can visualize transverse toroidal oscillations which constitute precession, in this case, considering a rigid coil oscillating near its equilibrium position with a fixed value of current density that. It is also to be noted that in the macroscopic models of the current density wave state, we consider the case of soft systems where external field influences the form of the wave function of the electron-hole pair. This results in strong mixing of toroid and ordinary polar oscillations. Okay, what are we talking about? Well, this is the image I chose for the cover slide today. So what they're saying is that the toroidal moment can either be up and less up, so it's oscillating here, but in a straight line, or it can process. And what do I mean by that? I'm going to get my props here. So we've got our toroid here, okay, and this is our how should we put this? This is our toroidal moment, and it's like precessing like that. So actually, the up and down would be something like that, right? And the precession would be something like this, okay? Now, if you imagine that this is actually just, the intense beam is actually on the outside of this, right? As it's processing around. So in fact, it's like, I don't know, how can I do this differently? What have I got? I'm going to use my microphone here. Am I going to use my microphone? Maybe I can use my microphone. Right, okay. So you've got this going up and down like this. Yeah, like that, okay? In the center. Or you can have it going round like that in a precession. God, if I can get this right. I'll look at what I'm doing. There we go. Got a precession. Or you can have a precession where it's going up and down and round and round, okay? All right. What I'm saying is that if that was to happen, you would end up by producing a Sothic triangle, okay? Because you would have a hole in the middle. So you would get what we observe on the this one. Where is it? So, you've got some moment that's twisting this, the torque on it. You've got some torque on here. You've got the magnetic monopole in the center that eats matter. In this case, if you've got it processing around, you would end up with a bit which is not damaged in the center, is essentially what I am saying. And that's that. So I've actually built a whole bunch of models here, and I was going to walk through, and I might do that today. I don't know. Well, I'll look at some things, but I'll do some videos. But I've created these little things, so I've made them in 3D now. So this is not all to scale, okay? So this here is more like the first one, A. This is going up and down. Actually, you know what? I actually created these models before I saw this paper. Anyway, so this is a toroid in the center here. This is our mushroom shape that it produces. And here's our other pole. So this is our kind of north pole and our kind of south pole. In fact, I should have did this a different color, actually, now I think about it. But what we see in the work of Bogdanovich, which is very, very important, is that when we have some of the same type coming together, and this one I've got precession on it. So this is a precession. So we got our cone coming out. So it's not our bit going up and down. It's our precession. So that's our two there. Is that the right? No, I've got them around the wrong way like that. Okay. All right. In the work of Bogdanovich, he shows that if you have the beamline going through a conversion target and then going through some magnets, on one side you'll have two poles coming together, and they follow each other like that. And that's because, like I say, I need to colour these bottoms differently, or swap them over. This is the north, this is the north, and these would be the south or whatever. They're actually the toroidal moments. They're not quite magnetic poles. They're these toroidal poles. They come together like this, and they join into a chain like that. But if it's where they did the plasma flow discharges, and they are looking at X-ray film there, they get a mixture of them. And in that image, if you go and look at my Azizi presentations from last year, you get them coming together like this, because one is a north and one is a south, and so they merge like that. And in fact, when you think about it, if these are approaching from any angle, that these fields only interact within a very tight distance. So the likelihood of them ever joining together like this is highly unlikely, okay? But they might be born like that, and that is very important to what we're seeing in the Vega experiments. They might be born like that, but if they blow up and fly away, you might have them coming generally able to join like this, okay? All right. We can have some fun with those as I do better and better demonstrations as I get my head together on it. what I've got here is it's not a funky earring. This is two poles, and these are our flux loop. Okay, all right. If that makes sense to anyone. Okay, all right. Okay, so I talked. Where was it? Here. Okay. So is there anything else I wanted to show in this? It's an incredibly good paper, this actually, by the way. You should look at it. Okay, that's measuring the moment, longitude and transverse, precession. No need for charges. Effect of force-free toroid. Okay, so therefore combined transverse and toroid photon oscillations can be described in terms of polaritons. So the interesting thing I want to note here is that Martin Fleischmann, I think he was even nearly nominated for a Nobel Prize for Raman scattering. And it's saying you could be detected in experiments on Raman scattering. And I wonder if, because of his level expertise in Raman scattering, that he was this was the connection at which he was brought in to do this work. I don't know. Okay, so that's that. Now, what have we got here? This next paper I've got. These might not be in order. Right. So this is from 2013. Monopole-based formalism for the diagonal magnetoelectric response. Okay, so we develop a formalism of the macroscopic monopolization. That is the magnetoelectric monopole. So this is definitely sounding a bit like the magnetotoroelectric structure of Alexander Shishkin. Monopole moment per unit volume in periodic solids, and discuss its relationship in magnetoelectric effect. Okay. So, what do I want to say here? I don't know whether I want to say everything here. In addition, the local toroidal moments associated with the volume V in... Okay, so they're actually talking here... Okay, so the atomic Cu in CuO have been detected directly using resonant X-ray diffraction. Okay, so they are talking about creating these structures. You can see this is at Los Alamos National Laboratory. Wolfgang Pauli... Switzerland, physics in Belgium, Royal Institute of Technology, Stockholm University, so on. Uppsala University. It's very interesting, isn't it? You've got Stockholm University, Uppsala, Los Alamos National Laboratory. God, where have I heard these names before? Just can't think. Okay, anyway, moving on. Such atomic site toroidal moments could be of tremendous importance, as it has been proposed that they are candidates for the order parameter in the pseudo-gap phase of Kuprick superconductors. These structures are superconducting. The second order term in a magnetic multipole, oh, that sounds like what we're talking about, expression contains two additional contributions beyond the toroidal term, which describe the turn magnetic quadrupolar and monopolar components couple respectively to the gradient and divergence of the magnetic field. See detailed derivation below. No, thank you. While the latter has not been extensively discussed on the grounds that Maxwell's equations tell us formally that the magnetic field does not diverge, it can in fact be non-zero in materials with a diagonal linear magnetoelectric response. Here we use the expression magnetoelectric monopole to distinguish it from the zeroth order term in the multipole expansion of the magnetic field, which is the magnetic analog to the electrical charge, and indeed formally zero. So normally it's classed as zero, but it is the magnetic analog, i.e. a magnetic monopole equivalent to the electric charge. We emphasize also that the magnetoelectric monopole discussed here is a ground state property of the system, and so is distinct from the monopoles recently proposed and verified in spin ice, which exist in excited state. So this is it just exists once you've set it up. So blah, 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 blah. Okay, so here we go. Figure 2, color online, representations left to right, positive and negative magnetoelectric monopoles. Okay, and it goes into the mass. We're not going to do that. For magnetoelectrically active multipole moments, such as monopoles, only the component is blah, blah, blah. Okay, all right. So people are thinking about this. What I find fascinating is just by looking at the Lion and the Hutchison samples, the physical damage, the only thing I could explain was something that was producing these cones, and it had to be a toroidal structure. It had to be a toroidal structure, okay? And recently, if you look at the video I asked people to look at earlier today, where we're looking at triangles on I think it was a 90-second experiment that I did, maybe a 180-second experiment that I did in Ultra Experiment, you saw these exact same triangles that we have seen on Hutchison samples, on the Lion samples, on the Vega samples, and so on. It's across the board. And I believe that that's because of the precession of the anapole, which I think is an analog of what Ken Shoulders is referring to as an EV, which is like a monopole. Okay. So they're talking about these metal phosphor structures, but also they're saying that it can happen in copper. So they're saying lithium and then a metal, which is manganese, iron, cobalt, nickel. So those are magnetic structures, magnetic nuclei rather, and then PO4 compounds. Okay. And so that's it. And you get these poles set up. Okay. Which are ground state poles. I'm not going to go into that too much, but just the fact that they are considering the production of monopoles, and it's related to the multipole expansion. Okay. So in the Hutchison effect, I'm going to have a couple of slides. If I look at this, let's see if I can find the right page for you here that I was referring to earlier. So here, is it here or here? Here. Okay, so this is a typical, or one of the key dumbbell. So this is dumbbell, like dumbbell, just like the same structures we're seeing in these metamaterials, but crank it up to the max. So we have our dumbbell, and around there we have toroidal coil, and this is the primary, continuous turn, 12 wire, 4-inch diameter. So this is a toroid of coil. Now, I can't remember which paper it's in, but they say that your toroid, your end toroid, has to be even for this to work. And this Cosmic Dave coil, it was even to begin with, but this is not even now, and this doesn't produce a magnetic phantom. I haven't rewired it to produce it even, now that I understand that it needs to be even to produce a magnetic phantom. But anyway, we will see if that works. But anyway, you will see these coils, and given the fact that one would imagine a ringing, an oscillation between here and the coil in the middle here, this is an oscillating electric field with a toroidal current. An oscillating electric field with a toroidal current. What are we talking about here? We are talking about an oscillating electric field with a toroidal current. Okay? Toroidal current. Okay? Oscillating electric field with a toroidal current. So, over the last several years, I've described how you can produce exotic vacuum objects from anything from the fast emission of electrons or other charged particles from an alpha, beta, gamma source like uranite, and they used a chamber with uranite in it with a window. That would produce a beam of things, right? This produces these charge clusters, which, if they are correctly formed, will be able to get into a state where they can go into metals. And once they're into metals, then they can sit in there, and then using a system like the Hutchison used here, where you have an oscillating electric field with a current in a toroidal fashion, I believe that you will be able to communicate with these anapoles, which I believe are equivalent because of the description of what they are doing, i.e. they are not radiating electric or magnetic fields because they cancel each other out because of the phase conjugation, the phase destruction, but they do emit scalar waves. So this, I believe, is a scalar energy transmitter, and the exotic vacuum object, the anapole in the Hutchison sample, is a scalar receiver. And as I said before, a capacitor plate with a small toroidal coil is said by the inventor of the understanding of these things, this chap here in this paper in 1989, but probably in work that he had shared in the 1960s or 70s, but certainly he would have talked about this in the Joint Institute of Nuclear Research in Dubna, VM Dubovik. He's saying that a capacitor plate with a coil can show the toroidal movement, okay? And what Hutchison is doing is he has got an electric field, maybe oscillating or whatever, but anyway, with a toroidal current. And if that's the case, I believe that something along those lines will be able to interact with these structures and charge them. And because they then become a store of magnetic energy, when the magnetic energy gets bigger and bigger and bigger, and those structures, what you will see is what you see here. You see these Sothic triangles, and we've looked into these Sothic triangles, and in there you can see that it has got substructure of these toroidal structures that are scalloping away. I believe they're forming a macrocluster, and the macrocluster is getting so intensely magnetic that cold, it twists and bends this. This is the torsional moment of the anapole moment. The torsional moment of the anapole moment. So anapoles, which Ken Shoulders called these monopoles, effectively they act like that, and there's a bit of confusion between them anyway. What you can notice on these two samples, actually, the knee sample in ferromagnetic material and this in paramagnetic aluminium, is that they are effectively the mirror image of each other. So I imagine that the cluster, wherever it was, we know from the work of what's his name, Leonid Oredzkiev. We know from his work that if he took a normal magnet on the back of an iron-57 plate, 0.7 of a meter away from a reactor, and a different 0.7 meter away from the reactor, he had the south pole of a normal magnet on the back of an iron-57 plate, that he could collect charges and obviously would be repelling. So like you had a normal magnet and it was coming along, and if this was the iron 57 plate, and on the back of this you had the north, and this was the south, let's say, and it's coming in, it would be reflected away. Would it be reflected away? Yeah, well, anyway, one or the other, and it would aggregate, and you get all these things building up on there, and so you would get it to the nucleus, and it would change the magnetic moment. So I believe that possibly, because John Hutchison also did this, he would often have a magnet in his experiments, and the magnet might be, depending on its orientation, collecting a certain type of monopole, right? And in this case, it collected one type of monopole, and in this case, it collected another type of monopole, okay? Because they're rotated through the opposite direction, if you can get my drift. Okay, all right. So there we go, the opposite direction. Okay. Okay. You could dope evos into metals. They infect metals. If they're mobile, they can like move through metals. Okay. So, do I have any other notes on that? So basically, this is essentially the Hutchison effect. And then once you've got the monopoles in there, you can use scalar fields, scalar waves, and when you've got intense magnetic in there, you know, they're going to be affected by these things. Anyway. And of course, when you get intense magnetism, these things cluster into spherical clusters or whatever, you're going to get this collapse. The matter will collapse. And you will always get this twisting going on. So plenty of samples get twisted. And I believe that's the torsional moment of these clusters. So I'm hoping that it's all being demystified. I'm annoyed that Wednesday last week, the fascism going on is preventing myself from meeting John sooner rather than later. But I believe all of these things happen for a reason. And again, you can see here, toroid, 3-inch diameter, 10-inch diameter section. So here's a toroid on the top, and I believe the toroid would also produce this vortical sort of this interaction in the same way that you're getting here, depending if you've got an electric field and so forth. You'll be able to communicate with the EVOs. But I think that this particular structure, this one here, is really key, this dumbbell, because if you look at all of the examples here for how to interact with these toroidal moments, they are effectively not these ones. I'm giving a bad example now. Where is it? Is it in this one? Well, okay. So these are dumbbell structures here. It was in the previous paper, wasn't it? Not that one. Maybe it's the next one. Is it this one? I think it's this one. Yeah, okay. Oh, okay. So here, if I zoom into this, this is a dumbbell with a gap in the middle, right? Dumbbell with a gap in the middle, rotational. Oh dear. Play nice with me. Dumbbells. Okay? All right. You get my drift. So I believe that's why this works so effectively. It is a very, very large version of the structure itself. And given the fact that, you know, whatever it is that you want to communicate with, you need it to be a receiver in the same way that it transmits. So, yeah, that is a dumbbell. In fact, he calls it a dumbbell Tesla coil. Oh, Tesla made these things. Yeah, of course he would. Yeah, right. Okay. So, and that communicates with that. Okay. All right. So, yeah, so I was talking about this earlier. And of course, this is the torsional thing that you get, I believe. It ends up creating a vortex. And I think I'm probably going to leave the material studies from Henk maybe till next week. Because I think that's probably enough for today's presentation, really. Because I want to be much more thorough with how I'm going with this. But essentially, when you are looking at this 10 yen coin, this is one side and this is the other. This is one pole and this is another. And this removed material and it slapped it down, and this is raised. This is actually, it came from here and punched it down into there. And so this is kind of, I'm going to do this. So let's say our north here is in the left-hand image here, is the one that's ripping the material apart. So we should have it round that way for your viewing pleasure. So Why is that mirrored? I don't know. Okay, so we've got the north here, and it's ripping it and punching it over there. And this is the flip side, so you're looking at it around that way, and it's pushing this copper out. But you can see it's like a laser cut. So inside the field of influence of this Evo, it's 100% effect, and outside it's no effect at all. Okay, and this is these structures coming in. So this one, and you can see the toroid on there, and how it interacted with the surface. Okay, and so this is the toroidal moment here. Okay, and this is a mixture of our two poles here and how they join together. So this isn't quite accurate. This isn't quite exactly what we saw on the previous slide. Okay, all right. And this is obviously, I've talked about this before. This is the material coming. This is possibly up to 12,000 years old. It's from northern Iraq, from Samaria. It is the shape that we see exactly for the yin and the yang. So the I think the that way round in this case. You've got the breaker here, and then the maker. So the breaker is taking out a bowl shape from one side, and it slightly overlaps. Oh, where did that go? Okay. And everyone knows that there's two types of swastika, a left and right, and of course there would be. And you've got particles coming out of phase, incoherent particles coming in and becoming in phase and coming out. So this is debossed, and this is embossed, or embossed and debossed. This is debossed. So these are above, coming in on the outside of the vortex, going to the center of the vortex, coming out of the center of the vortex in phase, so coherent particles. So whoever made this mass-produced lantern in northern Iraq knew how this technology works. And do you want to let them reset us again and rewrite our history and write a storybook for us all to believe in and stuff? Or are we going to take charge of our own destiny, knowing that this is a reality? That's the question. And here's your vortex-anti-vortex pair. This is in Matsumoto's work. This is in the 225-day reactor from Alexander Parkhomov. And these are the spheres that you find. Anyway, I recommend go back and looking at Coherent Matter Traveling Wave Beams Part 1. It's really talks about Messiats and so forth. It really goes into these structures and how they manifest themselves. And obviously you've got the one where it's boring through. So this is a pair, and it is boring through. Oh, I don't like this. Like that. And it has the flux loop on the back here with the material linking these two together. So they can be quite tight. So I'm going to actually go and look at the first slide, which is the cover slide. And I'm going to explain it in context with with this thing that I was wanting Henk to say something when I was recording this video, this hexagonal dimple. He was very excited about this hexagonal hole, or sort of hole here, but this hexagonal dimple. So I'm going to take a break here, and you can look at that, and I will be back in a little sec. So give me a second. Okay, I'm just going to look at the, before I do that, I'm going to look at something from the Bogdanovich long-lived plasmoids paper. So let me dig that out, because that is very key here. It's not something I've really talked about. I mentioned it a couple of times, this particular aspect of it, but I think it's important to get a grasp of what we are looking at here now. So let me get that. Okay, that's the first of them. Actually, for those that want to, there's the toroidal moment on Wikipedia. Toroidal moment is an independent term in the multipole expansion of electromagnetic fields, besides magnetic and electric multipoles. In the electrostatic multipole expansion, all charge and current distributions can be expanded into a complete set of electric and magnetic multipole coefficients. However, additional terms arise in an electrodynamic multipole expansion. The coefficients of these terms are given by the toroidal multipole moments as well as time derivatives of electric and magnetic charge multipole moments. While electric dipoles can be understood as separate charges and magnetic dipoles as circular currents, axial or electrical toroidal dipoles describe toroidal charge arrangements, whereas polar or magnetic toroidal dipoles, also called anapole, correspond to a field of a solenoid bent into a torus. Okay, so this is what we've got here, and here's the interesting thing that I think is quite good. Magnetic toroidal moments in condensed matter physics. In condensed matter, magnetic toroidal order can be induced by different mechanisms. Order of localized spins, breaking, spatial inversion, and time reversal. Oh, time reversal. Okay, okay. This sounds a little bit like our friend who warned us all that the Soviets were way ahead of us. The resulting toroidal moment is described by the sum of cross products of blah, 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 blah. Formation of vortices by delocalized magnetic moments. Interesting. On-site orbital currents as found in multiferroic CuO. Oh my God. Is this why brass is so good? Because it forms this cupric oxide rather. And so it builds the environment that's very good at creating these orbital currents, which we have seen physically in the Lion cupric oxide actually produces these structures. Orbital loop currents have been proposed in copper oxide superconductors. That might be important. Anyway, I think we've done it. And there we go. All right. Not that one. Okay. Give me a second. I've got the wrong one. Okay, so I think this is a seminal paper by the National Nuclear Research University, Bogdanovich. Video recordings of long-lived plasmoids near objects exposed to remote and direct effects of high current pinch discharges. This is it. This is very similar to what Suhas Ralkar was doing in India. But here is the interesting thing. We've got our toroid structures here and our plasma ball type structures here. But look at this. You have a blob at the end of this, and then a luminous thread, and then a blob at the other end. Spherical plasmoid and luminous thread in the discharge circled. Okay, so what does he refer to this as in figure 3? Figure 5, figure 2, figure 3. Okay. Spherical plasmoids are observed both in the volume and on the electrode surface in the absence of the main discharge. Figure 3 and 4. The glowing filament with a length of up to 1 centimeter, blah, 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 the ends of which are thickened, were discovered. The duration of their existence, as a rule, does not exceed units of seconds. Video and photography, blah, blah, blah. Okay. Anyway, the point being is that I believe that this is a monopole at this end, and this is a monopole, and this is the flux loop that's going between them. Okay? And so you can imagine it something like that. And we know that these structures, these flux loops, exist on the Lion reactor, and we know something after the Lion reactor was shut down caused some 2 spots on X-rays. And so I believe that's what's happening. And so it wasn't that the material was flowing through the copper. It's that the fact that you had 2 poles, and they were moving something out of the reactor and interacting with the material. Okay. I think maybe... do I want to show anything else in... This is recording a long list. Okay, so in this recording, this is the vortex from the top. He says this is the toroidal object that performs translation. This was lasting up for 2 days. This is a cluster thereof. This is their interaction. This is interaction with the dielectric. This is the neutral component going through the dielectric, and so forth. But in his previous paper on this, he shows that they produced these birdies in this. This is the Plasmoids discharge equipment. And so this is a luminous object coming out here. These are the images you've just seen. A white circle identifies a luminous filament. Now, I think they talk about this in more detail here. Figure 3. Figure 3. Where is it? Figure 3. Figure 3. Do they? Do they? In particular, there were some luminous filaments up to a few centimeters long, having an increased luminosity at the end. In some cases, these filaments hung in the air. In other cases, one of the filament's ends extended to the grounded substrate, and the overall pattern resembled a firework. Luminous, long-lived plasmoids were observed in experiments following years too. So this is from 1995 to 1996. That's their start of their work. Okay, so this is in the case where you've got a mixed anapoles or mixed monopoles, whatever you like to refer to them as in this case, and you can see that these you have them coming together like this. They're coming together like this. So those 2 are coming together like this, and this is what I'm talking about. They are more likely to do that, and you can see several cases where that's happening. So you've got one there, I don't know, but maybe one up here. But the clearest ones are coming together, these two. And he highlights this for a reason. I mentioned this in my Azizi. He's doing this for a reason. Now he uses a synchrotron through a conversion target. A magnetic field pulls the electrons out of the way. Gamma rays go through. But on the X-ray film, this is where the gap is, and the gamma ray or the whatever is exposing the X-ray, but below and above you've got the poles of different type because the magnetic field is shifting them either side. Okay, and you have them coming together. Okay, so in this case it's like they're coming together like that. It's the same pole coming together, right? Because it's on one side of the magnet, and I talked about that, as I said in my Azizi presentation last year. So you know that you can use a magnet to guide one type into a sample, and I believe that that's what John Hutchison did to create this one twisting this way and this one twisting that way. Okay, and so if you want something to build up with a single type of pole, you would want to guide like I say, one type in there, and if it gets up to a certain cluster size, it's going to start tearing it apart. Okay. All right, I think that's all I want to say with that. Now I'm going to show you this was I just, well, I wasn't showing you the image there, was I? So these are the two coming together with the magnet, because we got our magnet here, so it separates the two types of poles. And we know from the Oiritskiev work that you can collect poles. So this is two of the same type coming together on the side of the magnet where they're all the same type. And this is in the plasma flow discharge where you've got two of a different type coming together because they are mixed, and they've got another two of a different type coming together. Okay. Okay, so now I'm going to look at this. Now, this, I don't have the sample, and I kind of wish I'd taken it, but the advantage of taking very high quality video, so thank you for to Charles for making this possible, to be able to take this video at such a high quality that I can review from screen grabs of the video later what I want to talk about here. So what we are going to be talking about is this experiment where Henk was looking to see what gap made the effect. So he had a piece of iron, thick iron, ferromagnetic, and a piece of the diamagnetic copper at an angle, like something like that, okay, as a plate. In fact, plates were kind of that kind of aspect, okay. So it had a gap, and the action occurred down in the crack mostly, and less further away. But on one side, he highlighted this hole. But when I was watching, I saw a dimple. And so what I've got here is a composite. And so this is roughly where it was on the plate. It's not actually in the right position, but there's the hole, and there is the dimple. And as I said earlier, it has a kind of a hexagon shape to it, okay, which is the sort of thing we expect with this thing. Does this have a hexagon shape to it? Maybe. Maybe it has these vortical nature bits around it that you see on the Hutchison samples, okay? But this is the inside of it, okay? And very interestingly, you see the same type of effect that you see on the 10 yen coin, which is also copper and zinc, but the 10 yen coin is like 97% copper and, 96 to 98%, or 95 to 97% copper, and the 2 to 4% zinc and 1% sometimes tin, but it depends on the issue of the coin. But you can see that you have almost like a yin-yang side on here, and then you also have a yin-yang side on here, okay? And so this is two spots on either side of this structure, and you have an area where you've got a lot of deposited copper and brass, essentially, and then an area where it's kind of removed. And you're going to see a lot of this as I look through the top of the Vega Valley in another session. Okay, what are we talking about here? Well, what's gone on here and I'm going to draw in some lines. Firstly, this is the hole, and the hole lines up with this side of this splat. Okay, and the dimple here lines up with the center point here of this structure here. Okay, all right, and so what have I got next? I have, is it this one? Okay, so what I did here was I drew around the features here, and then I distorted it to line up here so that I knew where everything was going. So if I turn that off, this central point here lines up with wherever it is on here. So if I put it back, no, not that one. Is it? What have I done? No, not that one. This one. No, not that one. We'll come to that in a minute. Where has it gone? Not that one. Oh dear. Okay, and I turned what off? What did I turn off? I turned that off. Okay. All right. Okay, so you can see this butterfly bit is that butterfly bit, and because it's difficult to do this necessarily in your head, so I've done the work for you. Okay, and so essentially the area here. Sorry, I thought initially this was the hole for the other side because I don't have the sample in my hand, but it isn't. It is here, and you can see where it lines up over there. Okay. And in fact, I have that piece which I have overlaid. Is it there? There. Okay. So this side here is where the hole overlays onto the top. And this center point here is where you have the dimple. Now, when you're thinking about this, firstly, I'll put the flux lines on there, which are these ones. Okay. So I'm going to turn off these bits. So this is our north, but it's our toroidal moment on one side of one type of toroid, and this is the south of the other one. So this is material is coming down through the top of this. So it's going through this hole, out the hole, and down onto the metal surface. This one is coming out of the surface, through the hole, and it isn't going all the way through. It's not going all the way through. Well, that is the same, isn't it, as the 10 yen coin. If we go back to coherent matter wave part 1, or any place where I've shown this, it's not going all the way through. This is the backside. So this is effectively the north. The material's going through here, going round in a loop behind through the table and coming down, and it's depressing this out. Okay? It's depressing, but it's not removing it. It's not removing it. It removed this, but it's not removing this. Okay? So this is the top side. It's removing this, coming round here and dumping it down on there. Removing that, going through the table, up and round there. So that is the same thing going on. Okay? It's causing this to move, but it's like not melting this at all. Not at all, and the 100%. 100%. This is 100% affected. Not at all affected. We see this also in the copper pipe that has been affected. So in Vega. Okay, so so one might say, oh, this is just a gas bubble. Well, no, it's not a gas bubble because you have the metal like that. And the bit where you're seeing that lump there is kind of like up here. So there's no gas bubble in there that's pushing it through. It's a force. And I believe that you have the north, which is scraping material off the top of the iron and from wherever it can get it. And it's throwing the material up. But is it throwing the material? What is it doing? Is it doing this? Is it collapsing the material and putting it into a wormhole? Putting it into a wormhole, right? Like here. Is this the same as the anapole? Is that Matsumoto's interpretation? And we have that structure here, and it's grabbing all the material and it's putting it into a wormhole. And it's coming down and then it's splatted out at the other side. So, yeah, so that's essentially that really. So the hole is just off. I'm going to remove the Mari lines there. So it's going through there and up through here and producing this dimple. So for me, this is one of the most amazing samples that that Henk has produced. What looks like just a hole and is a melt, it's not. And there's something more significant going on here. And the image that I shared from the top of the Vega Valley, from one section of the top of the Vega Valley, is the same thing. And I believe what's going on here is that you actually have these multiple toroidal structures, and they are actually in the surface at an angle, and you're actually seeing the effect of this part of the torus producing these oval shapes here, right? Because this is at this angle and this is at this angle. Okay, so you got one like kind of like a dome there and another one here, and I'm not so sure this isn't also a fractal component of it, but I'm reserving judgment on that until I can examine the sample in more detail. Okay, but this effectively is a replication of what occurred on the 10 yen coin, but not in an HHO system, but in an HHO system, if you know what I mean. One is self-organizing without applying the gas, and the other one's self-organizing with the gas. And what is relevant right now? The same structure is also on the 10, not the tungsten affected by a Mars gas as well. I thought I had the image easy to hand, but I don't know whether I do. No, I don't. No, I don't. Maybe I don't. No, I don't. Okay. Anyway. Do I? Okay, so anyway, the point being here is that you haven't got any melting going on around here, but you've got displacement of material. Is this jellified, or what is moving this? What is moving this piece of material and causing it to form a lump? It's this toroidal moment, I believe. Is it magnetic flux energy? Is it that which is doing it? It's manipulating the electrons? It must be, because there is some flow of a metal, and it's lifting it here and it's pushing it down, lifting it here and pushing it down. That is without a shadow of a doubt. And in a very conductive piece of metal, thermally conductive piece of metal, it's brass. So, and the interesting thing is, this sharp edge of this brass, which is directly in contact with this iron, it's not melted. But all of this has done weird stuff to it. This is not melted. All of this is doing some really, really weird stuff. Okay? But it's not weird when you understand it in this context. So I think that's probably where I want to leave it tonight. So I'm going to have a look at what you've said here. Okay. So Cosmic Dave, yes, this is going to... I had a big discussion with my wife today, and I said, look, I've known that this, obviously, what the implications of what you're looking at here, of all of these papers, right the way back to the 1960s and even before, but the work of the Soviet authors, this is the easiest thing to turn into weapons. But I believe that it is the same thing that Matsumoto is referring to here. It within these flux currents. In fact, I'm going to show you one more thing, which I think needs to be discussed quickly. So let me just get that for you. I think I did it here, did I? Yeah. Okay. And I'll leave that for another day. Okay, we're going to do that, and we are going to need ooh, I can show you the big image, can't I? I think. Let me do that. Not that one. Yes. Ah, yes. Okay. So, this paper, which we've discussed about here, this was funded by like, Shanghai Yongtao University, Lawrence Berkeley National Laboratory, Institute of Physics, Czech Republic, Kansai Photon Institute, Japan, New Photonics, Japan, Glasgow, Shanghai, Beijing. It was calculated on supercomputers. Moving electron vortices have been observed in laser interaction. So we talked about this. This is a phallico-soliton, and we talked about the fact that they calculated this 3.6 trillion electron volt per meter. Sorry, volts, 3.6 trillion volts per meter effective charge separation going on here on the front of these vortices, and the fact that the magnetic field is up to like 1 Tesla in this 40, I think it's 46 micron across, isn't it? Is it 46 micron? 20, 40, it's a bit larger than that, something like that, 20 something. 20, it's like 50 something, around about 40, 50 micron size. And they calculated the field was around about 1,000 Teslas. But in the head of this structure, i.e. in the center of the torus, the magnetic flux loop, in the magnetic flux loop, this is the shape of the currents. Okay, bearing in mind this is superconducting. Okay, it's saying here B represents the electric field vector and background space. No, sorry. Where are we? Shows the trajectories in the frame moving with the vortex. So this is the represents the initial positions of 4 selected electrons and so on. So this is a supercomputer calculating the trajectories of the electrons, and this is in the frame with the vortex. So coming towards you here, okay? They're going around in this mishmash. Now, when I look at this and I know that this is a vortex, could this be explaining the internal structure of what I'm saying? This is a toroidal vortex here, the flux loop, this is the flux loop, but because of the superconducting currents moving through there and the flux densities of those within this entirely crisply defined event horizon of the flux loop itself, could it be this kind of structure spiraling around in there that is creating this destruction to the copper? And we know this is real. This is real. This is supercomputer calculated, but this is real. So did they get close to what reality shows us? Or I think they probably did. So it's quite exciting, really. Where's that? That one. It's nice. Different kind of flux loopy thing going on here. Is it this one? There we go. So is that the result of this? Is this the forward path? I don't know. Anyway, these aren't very big, because if you look at this, that is 5 microns. So what's that? It's 3.6 microns across there. So that would be 1 micron. So 1 micron from there to there. So within that point to that point to that point, these are 250 nanometers. So this structure here is in the 100 nanometer range. This is very, very small. So this would produce extremely small particulates. Now, we know from what we've been saying over the years that we can load into metals these things. Now, we could create it like Cardone does in a piece of steel, just with sound, and it would create the points of transmutation from what he calls space-time deformation process. However, I believe it's because of these rarefaction pulses or these soliton pulses that are coming in, producing standing waves and this coherence going on, and you create these, effectively these anapoles or monopole structures in there, and then you can use a very, very low powered stimulation from a long way away. And I believe that if you look at the fact that the Tesla's Wardenclyffe Tower was a tower with a toroid on the top, and you had an electric field difference between the sky and the ground and whatever, and if you oscillated that, it might be able to speak in a scalar way in the same way that this anapole does, and I think it's basically the same thing. You could have a scenario where you had stuff in your steel and your aluminium that you could energize, and it would get beyond that duality threshold, and the material would turn into nanoparticles, and some of it would convert to gas and extremely small dust particles, but otherwise it would turn to jelly or just fracture and splinter. The other thing that's interesting about that is that, as according to Freiberger, when the matter, when the monopoles or whatever the duality angle, whichever way it's actually occurring, causes the decay of baryons, you're releasing these pions, and they decay to muons and electrons and photons, and these hit the coherent matter of the ball lightning, and they get down converted to thermal energy, soft X-rays, and UV. If you were close to that thing, you would get sunburnt. If you were very close, you would get skin cancers and cancers, because the X-rays are not very high energy. But, you know, if these things break up, you can get higher energies going on. So anyway, my point being is, you do want to protect yourself from the UV and the soft X-rays that these things will produce. Those things can be easily shielded, and then to shield against the magnetotoroelectrical radiation, which are, in my view, the electromagnetic phantom particles, these neutral clusters, which can carry stuff. I would suggest the use of the Shishkin et al. Patent for protecting against those if you were to create a generator. Okay. So I will talk about how now, knowing what we know, I can explain pretty clearly all of the anomalies the MFMP has had. I know almost exactly why the Halputov organization, EarthTech Texas, got very interested in us in 2013 when we had our emissions of what we called gamma at the time, but weren't, in my reading of it now, and so forth. So right, I'm gonna look through and then I'll do a quick review, and then I'll call it a night. And I'm gonna do, so I had the microscope set up and everything, and I wanted to walk through some really nice features that are on the top plate of one of the top plates from the Vega Valley, because it really nails this arrangement, and there's something that's relating to the EM sort of nature of why you get certain patterns and other patterns. But I really need to do that in another presentation. I think that's probably enough for people's brains today. Enough for my level of exhaustion. Right, okay. I'm going to look through, see if you've got any questions. Oh yeah, so Mescal has said who is behind the solid state NG summit that recently released a heap of info about Lena, NASA, DARPA, etc. Well, I can tell you that the US Army are going to be replicating Ultra experiments, and I've got other good news that Luciatna has, without any particular guidance on Vega, because he did this before, or his group rather did this in Germany before we released all the videos in the last week or two with specifics on the Vega setup of Henk Uren. He replicated and observed similar effects that we have published from Vega experiments. So that's an independent replication. I'm hoping that he will present some of this material in the coming weeks and months. And he's also replicated the Ultra experiment. He considers that that is the same phenomenon going on. And on that note, I asked people to look at the triangles in the Ultra experiment. So I'm just gonna pull that up because it's really a thing of beauty that we found in that. I think it was a 180-second experiment. It wasn't a very long one, maybe 90 seconds. Not as long as Alan's one, which was into the quite several minutes. Okay, so I'm just going to kill the audio here, and I'm going to make that bigger, and I'm going to flip. So in this one, this was aluminium foil, two sides. And this is a barely affected area, so the coherence hasn't had a chance to get going. But in this other area over here, there's a lot more going on. There seems to be some synthesis of material blending into one of these cones. But this is before I found the braided sort of area. This is in a different experiment. The braided area was one when I used deionized water, I believe. But in around the center between these two structures, so you got one here, not there. Let me go here. So you got a couple of structures here, one here and one here. In this area, in this point here, if we go in, we have all of these triangles here. And I believe, just as I believe the triangles in here, and the triangles in the Lion reactor, and so on in Vega that I've identified, they are all because of these anapole moments. And where is the matter going? Is going into the anapole? Or monopole, these toroidal structures, these exotic vacuum objects, are they staying there, or are they getting up enough energy and then they're clustering together into a bigger structure? I think that's probably what is happening, and so on. So here is a close-up, if I move my mugshot, on the knee sample, which I've been waving around. This is in the Lion quartz, on the split plane in the Lion quartz, and it's probably these structures that did the splitting. Interestingly, they're about 50% the way through the structure. This is a large one, but it isn't the largest on this sample. This sample we actually have with physically massive, what we probably can say are precession of anapole toroidal moments. And I believe that these vortex features are caused by them facing into the surface. Okay, so, and there is the structure that I drew in January 2018. So, and I said that this is the basic yin structure, the yang, and this is the magnetic core of the structure that leads to all these effects. And this is from the 2008 paper of Wisniewski. And this is the ball lightning that led to these structures from Reutzkerf, which we talked about. So these are the triangles that we see in this sample. And it just goes to show you don't need to have a long and expensive experiment to produce these effects. And I've got a lot of data to share on ultra experiments, so I'm quite excited to get to that. And I want to do some experiments with some rather expensive 5/9s aluminium foil as well to remove any impurity questions. Okay, I'm going to go back and see what your questions are. I'll go back to this image because I rather like it. Okay. Dave, they've already turned it into weapons, okay? So, like I said, I had this long discussion with my wife. I keep having this discussion with my wife, but really, today was a time when I had a deep moment of reflection, and it was kind of like, this literally can make abundance for the earth beyond all imagining, and I just see these news stories where it just seems so contrived. It just so contrived what's going on, and this is the solution if someone will let it be, even just for the fact of clearing up nuclear waste, right? You can see that very serious nuclear research facilities were considering this, and it doesn't appear to be that hard. You just use HHO gas from like a Mars gas, and immediately you're getting these exact structures, whether you're doing it on titanium or tungsten or copper. We have these structures exactly captured on the 10 yen coin and the tungsten. So definitely this is what it's doing. So yeah. So it might be till tomorrow before I'm going to put this image up with the various breakdown of it, and I'll also put the links up. I'll probably do this tomorrow to all of the papers, so you can really delve into them. So Jacob Mate is saying there is a filament in between the 2 points that does not travel through space-time. I don't know. I think it probably does. I think it's just it doesn't work in a. So I've got one more paper probably. Let me. It's very interesting, this paper. So let me get that one more paper. One more paper. I got one more paper. Let me see if I can find that. So it's actually the comment on the front page, but as we've seen it elsewhere. So this is the helical solenoid model of the electron. A new semi-classical model of the electron with helical solenoid geometry is presented. This new model is an extension of both the Parson ring model and the Hestonese Zel'dovich model. I know some people that would be very happy in this community for me talking about this. This model interprets the Zeta-Bewegung as a real motion that generates the electron's rotation, spin, and its magnetic moment. In this new model, the G-factor appears as a consequence of the electron's geometry, while the quantum of magnetic flux and quantum Hall resistance are obtained as model parameters. The helical solenoid electron model necessarily implies that the electron has a toroidal moment, a feature... Read that again. The helical solenoid electrical model necessarily implies that the electron has a toroidal moment, a feature that is not predicted by quantum mechanics. The predicted toroidal moment can be tested experimentally. Okay. So if we have a toroidal moment, then if we have these large toroidal moments from these large exotic vacuum object clusters, they are basically interacting with the toroidal moment of the individual electrons in this metal. And therefore, they are maybe exciting the electrons beyond a certain state in a non-thermal interaction way, such that there is some loosening of the lattice or crystal or metal lattice bonds, so that it jellifies or it just falls apart. Is that what's going on? Maybe. So someone's just said donut made of Schlinky. Well, if I'd have actually got round to presenting the other part, I would have shown you this. That is someone with a neon slinky doing it very well. Okay? Right. There's a couple of things. I haven't read this paper in full, but it's very, very interesting. So what I have skim read. So we'll go down here. Right. You're going to love this. Toroidal solenoid electron model. In 1956, Bostic, a disciple of Compton, discovered the existence of plasmoids. A plasmoid is a coherent toroidal structure made up of plasma and magnetic fields. So it is a coherent matter phenomena. Plasmoids are so stable that they can behave as individual objects and interact with one another. From Parsons' ring electron model, Bostic proposed a new electron structure similar to that of plasmoids. So similar to that of the plasmoids. In his model, the electron takes the shape of a toroidal solenoid where the electric charge circulates at the speed of light. In the toroidal solenoid electron model, we assume that the electric charge is a point particle and that the toroidal solenoid represents the trajectory of that point electric charge. In a toroidal solenoid, any magnetic flux is confined within the toroid. This feature is consistent with the idea that the mass of a particle matches the electromagnetic energy contained therein. Storage of electromagnetic energy in a toroidal solenoid superconductor without the loss of energy is called superconducting magnetic energy storage, SMES. According to the toroidal solenoid electron model, an electron is a microscopic version of a SMES. Well, I believe that this, my friends, is a macro SMES. Storing a lot of magnetic energy. And in fact, actually, Bostic talks about the storage of magnetic energy in these structures. Blah, blah, toroidal and poloidal currents, blah, 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 helical, what's it, jobby, right. This is, in contrast to helical solenoid electron models, these concepts are evident and a direct consequence of the model's geometry. Chirality is given by the secondary helical rotation motion. So we have chirality in these structures. Right. Toroidal moment. You'll recognize this bit. In 1957, Zel'dovich 23 discussed the parity violation of elementary particles and postulated that spin half-Dirac particles must have an anapole. In the late 1960s and early 1970s, Dubovik, who we've talked about as well, connected the quantum description of the anapole to classical electrodynamics by introducing the polar toroidal multipole moments. The term toroidal derives from current distributions in the shape of a circular coil that were first shown to have a toroidal moment. Toroidal moments were not acknowledged outside of the Soviet Union as being an important part of the multipole expansion until the 1990s. Toroidal moments became known in Western countries in the late 1990s. Finally, in 1997, toroidal moment was experimentally measured in the nuclei of cesium-133 and ytterbium-174. In 2013, Ho and Scherer hypothesized that dark matter is formed by neutral subatomic particles. These particles of cold dark matter interact with ordinary matter only through an anapole electromagnetic moment, similar to the toroidal magnetic moment described above. The dark matter can only interact with normal matter through an anapole electromagnetic moment, similar to the toroidal magnetic moment described above. These particles are called Majorana fermions, and they cannot have any other electromagnetic moment apart from the toroid moment. The model for these subatomic particles of dark matter is compatible with the helical solenoid electrical model. So, as I have said, Shishkin has found that he only produces these magneto-toroelectrical radiation for a period of time with his cavitator. His cavitator is doing the same thing as ours is in ultrasonic experiments in ultra, and as is done by what's his name, Claytor and Stringham in their ultrasonic experiments, and by Leclerc in his ultrasonic experiments. But in the case of the cavitator, which is like a Griggs machine, he originally designed it for mixing oil and water and then got very ill when he was nearby it, so he wanted to put some x-rays and he found these little birdies. This is Shishkin I'm talking about. He found that after a period of time it doesn't produce the birdies, and so we know that these relic neutrino flux is these microleptons, these relic neutrino flux is a pressure, and it's available everywhere, but it would appear that these things can condense them and produce beams of them and clusters of them. And he found that the device would only produce these for a period of time, and to get them to produce it again, he had to physically move the cavitator to a different part of the lab so that it would again start to produce these birdies on his x-rays. So what this is saying here, and what we saw earlier, that it was mentioning that this is a model for dark matter, is saying that these toroidal moments are the only thing that can allow this dark matter to interact with normal matter. And so perhaps that is what is allowing this thing to occur. A toroidal moment, an intense toroidal moment generated by this structure that formed in this Vega experiment by Henk Uren, has allowed a flux of cold dark matter to interact with this ordinary matter, and that in turn is interacting with the toroidal moment of the helical structure of the electron that is associated with the nuclei of this copper and zinc in this brass, and is turning it to a jelly-like state, as we observe in the Hutchison effect. I also didn't mention that in some of these papers it's talking about the magnetoelectric effect, where these things can cause the magnetization of non-magnetic materials. Okay, and so that is another big thing that's explained by this. In fact, there's so many things that weird things that are explained by this. It's almost comical. But anyway, one thing at a time. Let's go back to the paper. So here we go. This is our electric dipole. This is our magnetic dipole, and this is our toroidal dipole. Okay. The toroidal moment can be understood as the momentum generated by a distribution of magnetic moments. The simplest case is the toroidal moment generated by an electric current in a toroidal solenoid. Okay, so something like they had on the previous page. Is it previous page? No, several pages up here like that. Okay. And I think that's all I want to say with that one. Like I say, I haven't read that in much detail, but I think this is the important part. This ties this ties the cold dark matter, the N radiation, the Alexander Parkhomov with Alexander Shishkin, the fact that Shishkin worked at Dubno where all of this stuff was going on, and will clearly have worked with the scientists, and it's kind of all coming together really. So yes, Stephen, certainly ancient symbols show it, and probably, you know, as I've said before, the Maltese cross, the symbol of God-controlled power, around the neck of this Sumerian god, and we derive this 48 structure, and this is the 48 structure, and this is the flying disc of the sky gods. Read into that what you will. This is the hexagon which we just saw in this structure here. This hexagon structure here. We know that this is associated with ball lightning because they've been saying it for thousands of years. And I'll read this again because this is the Indian equivalent of the Slavic culture for the thunder god Preran, who is a defender. It says here, Indra in Hinduism, he is the god of lightning, thunderstorms and rains and river flows. Indra is the most referred to deity in the Rig Veda. He is celebrated for his powers and the one who kills the great symbolic evil Asura, named Vritra, who obstructs human prosperity and happiness. Indra destroys Vritra and his deceiving forces, and thereby brings rains and sunshine as the friend of mankind. We are currently in the period of Asura, the great symbolic evil. We are suffering the deceiving forces, saying that this is not possible. You've got to demand less. You've got to be doing less. You've got to be suffering. You've got to be eating less. You can't do this. You can't do that. You've got to pare back everything. No, the god of ball lightning, this god of ball lightning can defeat this evil forces that are deceiving us and what is achievable by humankind. Jacob Mate, I will refer to the bag symbolism. Not now. Okay, I'm just going to quickly go through. Essentially, the big reveal today was, very briefly, what have we got there? So we started off with our cover slide, which is tip of the pyramid. Here, and we had this thing here from Dubovik and Tugashev 1989, which showed our up and down toroid moment and our precession toroid moment, and the combination of the two, I believe, leads to the Sothic triangle. And I think the overall thing is the birdie is effectively the key. That is the key to all hidden knowledge. That is the lower part of the ankh, from which the Christian cross was developed. And so you have this feature here, which I said I would talk about, and which stood out to me when I saw it. But anyway, the Russians have known about this since the 1967 from the paper written by Dubovik as his thesis. What a thesis that must have been. I mean, God, that guy should have had a Nobel Prize. But anyway, I didn't have any mathematics. I had no idea what I was looking at apart from when I saw this. I thought this must mean something. And I came to think that these two structures down here were the best representations of them. These are all a little bit twisted, so it wasn't so clear. And I showed that this one, I believe, with a circle in the center, this torsional thing here, and these slightly larger wing than the other, it could only be described by something that was a toroidal structure, and that had some sort of thing that came down from the center of it, this disruption beam. And that this one showed me that something was ripped from over here and thrown over there. So you got the toroidal moment, but also there's the bit that's unaffected in here, so it looked like it was hollow in the center. These are the top surfaces, and we've gone through this a million times. This is the north and the south, so I knew it was a flux loop. This told me that it was able to manipulate diamond into tubes, and so it was doing something very, very weird to electrons. There were these mirrored structures here, and what are they pointing to? Well, the answer is now they are pointing to each other, and this really finalized that for me in recent months. When I finally got this sample under an SEM that could see it again. And this is the Eye of Ra and the Eye of Horus. And it's all in cupric oxide, CuO. And this is where the so-called modern modeling of people that are trying to achieve what we've got here, they're trying to achieve it. This is very, very large. This is kind of like theoretical, kind of just about can detect it on the side of a very sensitive equipment. And here we go, very large, very large, very large, very large, very large, very large. And these are all what they're trying to do in the most modern research here in cupric oxide, the same stuff, right? Okay, so they're creating a toroidal moment. I referred to basically the only bit of Ken Shoulder's book I'd read, which I read on Rex Research when I was preparing my presentation for last year's CC conference, CMNS conference. And this oscillator is the perfect generator for vector and scalar potential waves without contamination from electrical or magnetic fields. Okay, and that led us through to the monopole clutch, because if it's a monopole, then the monopole can decay matter, and we've given a number of different ways that it's proposed to be able to decay matter. And then I referred to this paper here, which is observations of currents in copper. So that's the one where I got that from. And then I talked about how you can use sound and vibration generally to create solitons by either creating solitons directly or creating rare refraction pulses that can interact to create solitons. And this can occur in all Lena systems, all systems where you get transmutation occurring. This is the key, and it ends up with these toroidal structures, which then end up with the this anapole type thing going on, where you have an electric dipole in superposition with the poloidal currents, and because they oscillation in appropriate phase difference and amplitudes, you get phase cancellation, and so you do not get any EM fields, EM fields, but you get propagating scalar potentials going out. Then I talked about more work in this area, which is all sort of bang up to date. You can see this when I'm zoomed in. It really doesn't like using the mouse, the touchpad rather. So this shows quite clearly, and so you'll be able to let's zoom out a bit. Okay, let's just like that. Okay, not too much. Anyway, some of the important things here is dynamic anapole is a non-radiating energy reservoir, and we learned later that that was a magnetic reservoir, and that there are lots of dumbbell shapes that you can use to create and interact with these things. And then I went back to 1989 to one of the later papers of Dubovik and with his colleague Tugashev on this, and I showed probably the most important thing here was measurement, which used a coil and a capacitor plate, and I showed that in the Hutchison effect it was the dumbbell with an electric field and a current going through a coil in the toroid. So this effectively is something that can speak to the monopole or anapoles that are in the metal. And so that explains how the Hutchison effect can work, and I showed with samples and the observations of what you would expect and what we have effectively replicated in Vega and what we've effectively replicated in the Ultra experiments and what we've effectively replicated in the OMA experiments. Okay, so longitudinal transverse. The most important thing here is this precession here, where you can get an up and down action, and you can also get the precession. Okay, and no need for charges, and it's a force-free toroid. And then you can detect it potentially with Raman scattering, and I thought that might be where Martin Fleischmann got involved and so forth. So that's that. And this is again also talking about copper cupric oxide and forming monopole structures in there. So there we go. We've got something moving towards monopoles from this anapole discussion in a similar sort of fashion. Then coherent matter waves, and then this last one here, where it is talking about the helical solenoid model of the electron, and if that is the case, and it acts like a anapole, which is the same as we know because Shoulders started from Bostic, and so the plasmoids are. Bostic thought the electron was the same structure, and if it is, and the plasmoid is the same structure, and that is what led to the understanding of an EVO, and we have now my proposal, which is this clustered EM multi-level toroidal structure, which is essentially also thought about, but not specifically said in any literature directly by the Russian community even, but they did at least talk about this type of thing, which is an electrical equivalent of a n-order toroid that would occur in nature. But anyway, so the point is that it can store magnetic energy, and this, I believe, is what causes highly damaging effects. Because these things can go through metal, but if they get excited when they're going through metal, then they could then blow up and release their magnetic energy, and this was why it makes it unpleasant for various different reasons. But anyway, this explains how you can use something like this thing to interact with anapoles. Where is it? Anapoles. You can use the Hutchison effect structure to interact with these exotic vacuum objects that you have in your metal, and the most fundamental thing that you would have in your metal that is an anapole effectively is your electron itself, and therefore you could maybe, by focusing these things with phase conjugation or cymatics between two of these scalar wave generation devices, you could have effectively a crossing point that could take the electrons that are already in the material and start building large anapole or monopole structures in there, and so then it gets a bit funky. And so there we go. I think that's probably enough. So I'm a person. The project wasn't set up ever to make a working embodiment. The project was set up to pay attention to what other people had done, both living and dead, test their claims within the capability of the donation of time by the volunteers, or the donation of the time by people that are interacting with the project, and a donation of funds and other resources, to the best of everyone's abilities, given the fact that we're not supported by monolithic military organizations or well endowed universities. I think to be able to go from receiving a sample to having a model of what at least in basic principle within a few months of what was causing it was one thing. To be able to have it verified all the way back to the 1960s that not only it was this structure, it's real, it's in there, and it can do all this funky business, and that the way that it sends information out is the way that you would charge it. I've always had a belief in my life that you measure twice and cut once, rather than stabbing in the dark. We're at a point now where you literally know that this is real, and that when we had our first meetings with the MFMP, it was kind of like, we don't ever have to do this. Actually, we just have to show with clarity that this is possible, and then there are millions of people out there that will run with it. I never in a million years imagined what is possible with what is the underpinning this technology. In my wildest dreams, I could never have imagined it. As I said at Aarhus, long before I was anywhere near the level of understanding that I hope we all have now, I was saying there will be whole universities where there will be many different departments that are studying how to get the most out of various aspects of this technology. And actually, that is already going on, except they're calling it something different. They're calling it anapoles and they're calling it whatever. But, certainly the first person that published anything in 1987 that was referring to something that could do the crazy effects was because of John Hutchison. John Hutchison produced these effects in 1979. Okay, so Dubovik, what was his first paper? It was in 1967. But I don't think John had any attention to that, and there we go. So John did physical things with this that I guess were only concepts, maybe outside of the highest level military technology, because, like I say, I believe what is referred to by Thomas Bearden as this agreement between US president and the Soviet leader back, I think, in the 1970s, was referring to this research in this field. But people are researching it. This is like they're researching it. This is in Nature Materials, and it's in 2016. I've got papers from 2019. So people are going on and researching it, and they're just trying to call it different things, and they're still modeling, and they're still creating little tools that show something going on. But there isn't. I guess it's kind of like making technology that isn't very threatening, I guess. But I don't know how you can argue that this is able to interact with the energy storage or the actual nature of the electron without thinking what that might do to particularly metals, for instance. I don't know how you can square that circle and think this wouldn't do that. And obviously it does. And so, with the Lockheed Martin coherent matter wave patent, they are literally producing electrons without crediting Ken Shoulders from a spike through an electric field using a magnetic field. They are literally doing it with the Aharonhof bomb effect, so to get them to cohere. So it is, and they say it's for particle beam weapons as well as propulsion and directed energy weapons. Directed energy weapons being different from particle beam weapons. So yeah. Yeah, I think a lot of people are talking about the same thing and referring to it in different technology. But what you can see from sound in water, I'll show something actually that really illustrates the point. I think how this is just totally ancient, and I think it's surprising that Well, anyway, you'll see. So you can go and have a look at this. It's on ultra crop circles, and this was a video I recorded with my pregnant wife with our first child, and he's was born in 2013. So you know, this is 2012, I think, and this is where I said, you know, if we're going to do Lena, we need to either whack it and create a sound and listen to the resonant sound and stimulate it with the resonant frequency, or caress it. And so we talk about that. How I would speak about this now is I would actually use this scalar interaction to interact with it. You can create the evos and get them to cohere and get more of them, but and increase their size. But the easiest way, I think, probably would be to create them and then an incredibly low power resonantly charge them. So it's very, very, once you've created the structure that persists, and according to the work of Bogdanovich et al., these things can persist for 2 days. And so you have plenty of time to charge them up. You can even take breaks from it. You could probably charge them up with a hand crank until it did what you wanted it to do, like created liquid metal molding or something. And so here is an example of how the cymatics, and I believe this is coherence going on, because there's a Californian research that I referred to a couple of years ago where they found that they could not explain this phenomenon with any hydrodynamic models. And what you're seeing here is it's a singing bowl, like I just showed you down here with my wife, and as within a few turns the resonant mode is set up and the cymatics, and it's launching these water droplets so high that they're actually flying off the top. Now, we have seen in ultra experiments that the yin-yang pair is created in just 8 cycles, and that is 43 kilohertz. So it's 8 43,000ths of a second you are creating a yin-yang pair. So it's almost immediate. And so the coherence is formed, and we know from our videos that in the cone, the trough rather, we are creating a vortex, but it's also a toroid. The toroidal bubble is formed in there. And so because of easy water and the dipole moment of water and the fact that it's spinning and it's toroidally spinning, you're going to get charges moving around, and you are creating a magnetohydrodynamic effect, and that this, you know, would lead to a proxy over the anapole moment that we're seeing. And this anapole moment would be able to interact with both the electrons in the material passing through the center of the anapole structure, but also with the Rayleigh neutrino flux, the cold dark matter that is all around us. So I believe that the coherence is occurring, and then as it decoheres and blows up, that is what is responsible for this. There's another example here of a singing bowl, but obviously it's a little more modern variation. Thank you for David Boutillier sent me this one. So almost instantly, you're getting crazy displacements going on. So there we go. And the Tibetans have had these things for a long time. So I think that the water that is treated in this way will be quite special. I think it will be quite special. Oh, great, Cosmic Dave. Great. Give us a video. Dave says he is going to try this today with his Tibetan bowl. Wonderful. Great. Send us a video. Yes, Steve. This is why it's tormented me for so long. I mean, the level of disruption. I said for the first couple of years that when O Day is fully understood, and it will be a different point in time for different people where they will accept it. But you know, now hopefully with today's presentation, with the skimming of these papers, people can understand that this has been known for a very long time in the Soviet sphere. This is able to interact with matter at this most fundamental level and bring in energy that is basically ordinarily out of reach and incorporate it. And so it's amazing. But being able to turn metals into a moldable form without them being hot, that has all kinds of implications, the sort of sword in the stone implications, but also, you know, what is a solid structure now? And I think as I said, in my first, let's pretend I'm in a mental breakdown, I was in shock, but I wanted to give shock to other people to see what I was going to say about Red Pill. I understood why there was a desire to hold this technology back from general use. But given the fact that it is clearly, in my view, being used by our species all over the planet before. Now, I don't know whether back in those days it wasn't just used by a select elite people that flew around in their anti-gravity craft and did party tricks, did some amazing works, made some elements and stuff. I don't know whether they were just kind of like dangling these symbols of power in front of everyone's face, and it's kind of like an in-joke. You know, there's this culture here in the Czech Republic, and to a certain extent in Britain, of this kind of humor where, and it's I think it's a bit destructive, where you have people in a group, and some people in that group know the in-joke, and they talk about it openly in the course of the group conversation, and they're kind of like getting a lot of enjoyment out of the fact that people are hearing the words, they think they're understanding what's being discussed, but they don't know what's actually the information that's being transmitted. And I think these symbols have been put into all of the Masonic art, and they've been passed generation upon generation, these symbols of power, and they are all relating to this technology, particularly things like the yin yang. You can see it's actually here on this, the logo of this website for this thing. But the yin yang and the fleur de lis, the Maltese cross, the swastika, all of these symbols of great power, the trefoil, and so on. These have been, someone is having a laugh, or some benevolent people gave us this information to pass forward through cataclysm. And it might have been for whatever reason, there was a cataclysm and the knowledge was lost, but it was written in stone all over the world, and it only takes people to pay attention to it. But given the fact that you have Bostic making these connections back probably in the late 1940s, I think in the 1950s, they would have had a discussion as like what do we release to the public? You know, if they just keep on using electromagnetic fields, they can do so much with that. For me, the problem is that the 166 times the energy output of DD fusion, this energy that I believe was what Boyd Bushman was talking about, that Lockheed Martin was looking into, the next level of energy, way beyond fusion. And he connected that with John Hutchison and the neutrinoverse in one video. I don't think that is a coincidence. I think that probably that video, that interview by Boyd Bushman, was the greatest gift that he gave. I don't think the Stinger missile was the greatest gift he gave. I think the magnetic pulse beam was a good gift. But I think that one video where he talks about this neutrinoverse, the John Hutchison effect, and the fusion, this energy technology that is way beyond fusion. I think he gave that one video, seeing that video, what I found is I've always enjoyed talking to how should we put this, mature people, because the closer people are to leaving their mortal coil, all of their ego starts to go away, and they start to think about what is it I've done with my life, what are the most important things that I could pass on to the next generation, and how could I do that in a way that doesn't make me look dishonorable with the contracts that I've signed, type thing, because people still hold those things in their mind. And so it's often best to listen to old people, as long as they've got their wits about them, because they're basically going to avoid all the BS and just cut straight to the chase. And I think for that, when I was looking at that video, I was looking at into his eyes as he was talking about these things, and he's having fun with being succinct in getting the message across that these three things are connected, and go and work it out for yourself. So it's kind of like an in joke for him as well. So yeah, it's moving beyond combustion energy to field energy, and it's field energy also, it would appear, that has the ability at a certain level to create ball lightning inside materials. But I really, we want to create the ball lightning that we're able to feed it, say, nitrogen and produce iron. And the energy gain there would be fantastic, just absolutely fantastic. So, I mean, if you take two nitrogens and fuse them, I think let's do that. You get two nitrogens and fuse them, you get iron in an exchange reaction. You get, I think, 15 million electron volts with a production of 1 aluminium and 1 hydrogen. Let's do that. So, let me just do that. It's no, don't want to go there. Okay, all right. So 2 to 2 reactions, and I think we'll have a nitrogen. In fact, we'll just do nitrogen and nitrogen. Yeah, so we don't want any neutrinos involved just at the moment, although they might be involved anyway. So the first one here is so as I said, nitrogen goes to hydrogen and aluminium, and that is nearly 16 million electron volts for that. And if you take 2 aluminium and you fuse them, you get iron 54. But if you took 2 aluminium and 2 hydrogens and do an electron capture on that, you get iron 56. So basically 4 nitrogens can end up as iron with 2 of the protons that are produced being electron captured to neutrons. Oh, and you need another 2 protons. But anyway, you get to iron with just aluminium 27. So that is potentially one way of doing it, and you're going to get even. So you got 2 lots of 15.95, and if we take 2 aluminium here on a fusion, so the fusion, and we do aluminium and aluminum for you guys in the States, fuse those, we are getting iron 54 with 21. So you're getting 30, 50, 51, 52 roughly million electron volts. And this reaction would occur all in one. And I'm saying the aluminium because that's what we've got in the Hutchison effect here, and there is iron in here. So we did the soliton flux loop spots on here in Sochi under XRF, and we see iron synthesized in there, and so I believe that is a valid reaction. Hi Elias, we're about to sign off. Okay, so thank you. As I said earlier, if anyone can help me get to what is it, Azizi, I think I will present something along these lines. I don't know whether they're ready for it, but it does follow my other presentations that I gave in Azizi last year. And I think what I'm going to do is I'm probably going to say, look, a hypothesis or a hypothesis to explain observations across a number of coherent matter systems, so condensed matter systems, because it's condensed matter, something along those lines. I've got to write an abstract for them tomorrow. That is I want to get this out there because I don't want any of the rest. The European money has been spent now for 2 years, and there's only 3 years left of funding, I guess. And I want to make sure that money is spent really, really well. Because we need the answer. We don't need to be doing the same thing over and over again that didn't work. There we go. I want to get that out there. So thank you very much for your time. I want to thank again Henk Uren for his amazing work, really, over the last 2.5 years, and always taking it forward, thinking about things and trying different things that explore the concepts that are being discussed. This particular thing for me, and the other stuff that we will show from the sample that I have here, is going to really settle this. But I think this settles it, because this is essentially what occurred on the 10 yen coin in the HHO system of a Mars gas. And it's this cannot be a bubble. It is a flux loop. It's doing something to the electrons. It is a hexagon. There's everything going on in here. And this is a macro structure. I mean, this is physically very, very large. And this might even be bigger than I think this is bigger than the structure that was on the original or the second line reactor on the outside of that that vortex pair. But anyway, so very, very satisfying, this particular sample. So thanks to Henk. Thank you to Stephen and Charles for enabling the purchase of the equipment that enabled to be able to look into the plasma and to take these excellent videos and so forth. And also to DK1204, I don't know his catch name there, but he helped support that trip, so thank you very much. And thank you to all. I haven't got the thank you slide here. I'm very sorry to my followers, but thank you to all those that support me on remoteview.icu. It really makes a difference to my family. Don't forget, if you haven't had the chance to get one of these, this really is, in my view, a seminal piece of work. And I'll talk about other things that I've acquired recently, like this one, in a different video. All right, so thank you very much. This was, what was it? What were we talking about? This was the O-Day at the tip of the pyramid, and obviously the pyramid is this thing here, which is the precession of the toroidal moment. And at the top of the pyramid, you have O. Okay, at the tip of the pyramid, you have O, and it's the toroidal moment that allows for the interaction potentially with the internal structure of the electron, and how you can do these funky effects. So thank you very much for your time, and I will see you in the next video. Buenas noches, dobro noc, buenas sera, good night.